That was me.
That's you?
Yeah, that's me emailing you.
Yes, it is.
So you can actually watch the 10-second lag version of what we're talking about. You can watch it live.
That's okay.
So this is our last doctrinal class.
What?
This is our last set of the last 2 slide decks. It's amazing how fast it went, right?
Yeah. Especially since work doesn't stop.
No, it doesn't. And life doesn't stop. Family crises happen. It's kind of awful how that happens, but
Yeah, no, work has been crazy.
you can't exactly put life on hold just because you're taking a test. She's away. He's in Pennsylvania. They would probably go to the bathroom?
Mike is here.
Yeah, Mike is here. Where'd he go?
Probably to the restroom.
Okay.
Oops, that's not being. We got 9 and 10 to do. Right.
Yeah, we got 9 and 10 to do, and we get to play a coffee. Which we've got a lot of coffee for not many of you, so that's what I'm
Oh, my-
It'll go. It'll get consumed.
oh, wait, he bought Starbucks and he did.
Yeah, that's the point, right? So what we'll be doing is we'll be looking at design of experiments. So one of the factors that we'll be looking at is how does the total dissolved solids measured by this guy, how is that affected by the store? Then we'll also be looking at it as how is the total dissolved solids and the temperature affected by caffeination. So the little cups are decaf. So decaf from Starbucks and Dunkin' Donuts. And then we will also look at the effect of on temperature and pH, temperature and total dissolved solids of contaminating it with these bovine lactations.
Contamination.
So we'll get there probably once we just go through our ANOVA linear regression and our regression section, which I'm not going to do any justice to. You can take several courses in regression in the stats department here at the graduate level, where they spend 14 weeks each, respectively, going over regression, and we're going to do it in like 10 slides. Sorry. Any questions for me before we continue? Did everyone get a copy of the final? I emailed it out last night.
I did.
Cool.
We gotta print it now.
No, that's fine. That's fine. I just want to make sure everyone got it. Since we're on a crunch for time, we'll be going over it next class. So hopefully you can get it done in the week. If you can't, it's not the end of the world. But as you know, we'll spend the entire class going through every problem on the exam. Unlike the midterm, which I said was about 20% harder than what you expect to see, the final is what you should expect to see. So
Thank you for that.
well, yeah, it's a half exam, so you get 2 hours. I think it's pretty good. You'll see 1 or 2 questions that repeated from the first, and just to give you a flavor of like, so that's what you should expect to see on the real exam. That 1 or 2 of the questions will probably be something that you've seen. I can't emphasize enough how important it is. The best way to study for the real exam, which is now in 3 weeks, 2 weeks, is to go back through the practice exam. So you now have a copy of the pretest. Go back through, and you have the answer key. Go back and score yourself. Keep going until you're scoring in the mid-90s. It's going to sound kind of silly, but you're like, wait, I took this test. I know the answers. And then you actually do it and score yourself. It's like, wait, how the hell did I score in the 70s? And then you do it again. You'll be in the 80s. And you'll be like, crap, didn't I just do this? And rinse, lather, repeat until you get there. Because as you've gotten a sense for, a lot of the difficulty on this exam is understanding what the question is asking. And the way you get to do that is through practice. The other skill that this exam is testing you on is your ability to triage. So your ability to be able to determine how to handle this question. Is this a question I immediately know the answer to? Is this a question that I know how to do, but it's going to take a while? Or it's a question I know it's somewhere in the book or it's somewhere in the notes and I just need to find it? Or is this just a complete red herring and I have no idea? So the questions I have no idea on, I don't want to spend any time on because I just don't know. I'm going to pick B because it's the best letter of the alphabet, and then move on to the next. So the way you get better at that is by practicing the exams. As I said, the midterm was a little bit harder. There was a little bit more math intensive. All the questions on there are free game. There was nothing that you could not expect to see. The only thing was there's a little bit more of them. So some of the Poisson type questions were 2 or 3 steps. You can maybe expect to see one of those. And I think on the midterm, there was 3 or 4 of those. But you also should be practicing the exam under realistic test-taking conditions. So if you're going to use the TI-36X Pro, which hopefully I've gotten converts from everyone, and if I haven't, well, yeah, I tried. When you're taking the practice test, use that. If you plan on bringing the textbook only to the exam, take it with only the textbook. If you're planning on using the textbook and the slides, well, do that. If you're planning on using some other reference material when you're taking the practice test, do it that way. You want to simulate it like you're going to actually take the exam. It's kind of like you want to practice the way you play. What else? It was kind of interesting. I did the sublight study with my 3 indulgers this week, and we actually showed via a t-test that it's statistically less than 12 inches. So in our 10 sandwiches, we showed that the average was 11.6. And that average was statistically less than the stated 12 inches for a 1 sample t-test. I thought that was kind of cool. Okay, any questions? Anyone do anything fun, interesting?
Not here.
Not here? There's no fun and interesting stuff going on? Oh, come on.
Was that a different region, Subways?
It was different. Each store is independently owned and operated. So this was the Starbucks in Eatontown. Yeah, this was Starbucks in Eatontown. It might be Ocean. I don't know where the border is. I've actually looked at that store before, and they're generally less than. But I think it's a cool exercise that it shows that you can use this 1 sample t-test to answer your question. Because when you use a 1 sample test is when you have 1 data set, and you want to compare that data set to a standard. Well, Sublight has a standard. We have some data. Let's compare it. Okay, so let's dive into this stuff. This is kind of not fun. So what is ANOVA? I need to fix that because that's awful. I apologize. Yeah. It's going to be hitting so nicely now. That'll work. Yeah, it's good enough. Sorry about that. Okay, analysis of variance. Even though it has the name variance in the name, what do we use ANOVA for? We use ANOVA for comparing what? You guys should know this.
Means.
Means, right? And what's special about ANOVA compared to the t-test and the z-test?
More than 2.
More than 2, correct. But what do we lose with ANOVA? See, in the 1 sample T, I'm sorry, in the 2 sample T, the 2 flavors, the 2 sample T, or in the 2 sample Z test, we can test our alternate hypothesis to be greater than, less than, or not equal to.
That's right.
In ANOVA, we can only test not equal to. We can only detect if there is a difference. We can't tell the directionality of the difference. Kind of an important distinction. So ANOVA will just say there's a difference. The t-test will tell you which way is it greater than or less than. And in some circumstances, we just care if there's a difference. But in a lot of circumstances, we're trying to prove that A is less than B. So what ANOVA tries to do is tries to look at the effect on your output as a result of a single factor. And as we'll see in our design of experiment section, the next slide deck and why we have the coffee here, is a factor is something in your model that you're going to change to different levels. So your factor is the thing that you're changing to different levels that affects your response. So we'll be looking at our response being the total dissolved solids and the temperature. And the factors we'll be looking at are the store, Dunkin' Donuts versus Starbucks, the contamination, milk versus black, or the effect of caffeination, so decaf versus regular. So those are the factors. So what ANOVA allows you to do is say, is there a statistically significant difference that is attributable due to the store, the caffeination, or the contamination. If you were looking at the effect of multiple factors at the same time, you'll be using a two-way ANOVA or a factorial ANOVA. So what does ANOVA do? What ANOVA does is it tries to partition the variance into two buckets. That's the between group variability and the within group variability. So what it's trying to say is the difference that I'm observing between these two factors likely to have occurred due to chance alone, or is the variation more than I'm seeing within the group? So what it really wants to do is take the sum of the squares and divide it into two independent parts. So ANOVA uses the F statistic. Anyone else remember when we used the F test?
Variance.
Yes.
Variance is the same.
Yeah. So we use the F test to determine if two samples have the same variance. So the test statistic in ANOVA is the group variability over the within group variability. So it's looking at the individual differences within the group and then looking at the differences between the groups. So when should you use ANOVA? So you should use ANOVA if each sample is independent and they've been taken from hopefully the same population. You're assuming that your data follows a normal distribution. One of the nice attributes of ANOVA is that it's fairly tolerant to non-normal data, but strictly speaking, it's only applicable to normally distributed. But we know that we can use the central limit theorem to do what? If we know our underlying distribution isn't normal, how can we use the central limit theorem and still be able to use something like ANOVA?
Form rational subgroups out of data.
Well, yeah. If we take our subgroup, if we take samples from that population and average them, and then add the averages, that'll follow the normal distribution. So yes, if we subgroup them and we look at the averages of those subgroups, the data will become normalized, and then we can use our normal tools. ANOVA also assumes that the variances are equal. It's actually very robust to the variances not being equal. And subjects in each group have been independently sampled. The independence requirement is actually important in ANOVA. So we've seen examples where independence is often violated. A great example of independence being violated is in reliability. So if I'm looking at my manufacturing process and I find a broken piece, does that change the probability of looking at the next piece and finding a broken piece? What do you think? If I observe a bad part coming off of my assembly line, does that affect the probability that the next part coming off the assembly line is going to also be broken? Yeah. In many cases, yes. Whatever caused that defect is probably still there. So if you have a die that's worn out, you have a motor that's burned out and isn't turning correctly, it's going to affect all subsequent pieces. So a lot of times in that case, you don't have independent observations. The fact that you observe one thing changes the probability that you're going to observe subsequent events. So independence is something that you always have to prove and demonstrate that these events don't have anything to do with each other. So if I flip a coin now and I flip a coin 5 minutes from now, there's no connection there. But if I were to observe the coffee, the temperature of the coffee now, and an hour from now, would those observations be independent? The temperature of the coffee now and an hour from now. No, it's going to cool off, right? The temperature an hour from now is going to be a function of what it is right now. Newtonian cooling. At the absolute, if it was a planet-sized thing, it would be Newtonian cooling and we could figure it out. Unfortunately, it's not planet-sized, but it's going to cool off at a complicated differential equation rate, but it's going to cool off and it's going to be a function of where it starts off. So independence is something always to be conscious of, is that in the real world circumstances, independence is not always true. Generally, the more you gain more information, and that changes your predictions going forward. But That's true and all. So in the case of ANOVA, our null hypothesis, remembering that our null hypothesis is what we assume to be true. We assume that there is not a difference in the means. So your null hypothesis, HO, is that mean 1 equals mean 2 equals mean 3 equals mean 4. What's our alternate? They're not equal. Okay, so how do we calculate the test statistic? So the sum of the squares between, divided by the degrees of freedom between, the sum of the squares within, divided by the degrees of freedom within. We have animations.
Other slide back up. No, the next one. Oh, okay.
Yeah,
Oh, okay,
they're animated.
all right.
You can tell I stole them from somewhere because they're animated. I used to joke with my reports in Mexico that the quality of PowerPoint presentations was inversely correlated to the quality of the information being presented. Such that quality. What way do you think the line goes? The quality of the PowerPoints and the quality of the information being presented. See, I argued it went this way.
Yeah.
Now, when you have a really nice PowerPoint, you're trying to hide something. And if you have really cool info, you're not going to spend much time on the PowerPoint because your information is going to speak for itself. So in this case, I have nice slides. Okay. So how do we come up with the grand average here? Well, we sum our averages. And we square them to get away from the absolute value, to the negative signs. So it's summed across all n times of p observations. So we're going to sum. Cool. So in this case, we're taking each observation and we're comparing it to the grand average. That's for the total sum of the squares. In the case of the between sum of the squares, we're taking each individual average. And we're comparing it to the grand average. Cool. As I said on the exam, if you were to see a calculate and ANOVA by hand, your response should be to put B and run away. But I feel compelled to walk through it just because it's in there. And then the within sum of the squares, you're just going to plug and throw. It's the sum of the square differences of the observation from the group means. So we have each observation and the group mean. So how different is each individual observation from its average? So you're basically doing something akin to the standard deviation calculation. So how do we determine the degrees of freedom between? Well, it's the number of groups minus 1. And the number of degrees of freedom within is the number of subjects in the study minus the number of groups. So its total number of observations is n. Good, okay. So how do we do this? So what it does is it compares the test statistic against the table value. So where do we get the table value from? The F table, which is not on page 374, that's the Greenbelt page. What page is the F table on in your book? You know?
529.
529! Okay, so on the F table, it has on the top column, well, first off, you need to identify what level of significance you're dealing with, right? because there's different F tables for different levels of significance. So
So fun.
at a 5% level of significance, yep. And then the top column is identifying degrees of freedom of the numerator, right? And the degrees of freedom of the denominator. So what's our numerator and what's our denominator? What's our numerator and what's our denominator?
I don't think we said yet. Did we?
Yeah, we did.
You hit it.
I hit it. Yes.
I or J.
Well, what we're doing is we're doing the ratio of the group variability to the within group variability. That's our F. So we have the sum of the squares between divided by the sum of the squares within. So it's between over within. So our degrees of freedom of the numerator is between. So it's the k group, k minus 1.
I thought you were asking for a number.
No. I'm just going through the, how do we know what represents the numerator here? So it's k minus 1. And what represents the denominator for our degrees of freedom? That's n minus k. Okay, so we have some data set here. So we have group 1, group 2, group 3, right? And it's kind enough to give us the means. So how do we get this? We know how to get, so we have our,
one way.
this is one way, yeah. Yeah, we want to see if there's a statistically significant difference between group 1, group 2, and group 3's means. So how do we get the sum of the squares 1 to be 20? What does that mean? What does SS1 mean? Any ideas?
Sample size?
Mm-mm.
Difference squared. Summed.
Yeah. So what it's doing is it's taking the average. It's taking the average, and it's subtracting from each one of these guys and squaring it. So 6 minus 3 squared, so 9. 2 minus 3 squared, so 1. 4 minus 3 squared, 1. Better. See? Okay, so that gives us a sum of the squares within of 46. The sum of the squares from group 1 plus the sum of the squares of group 2 plus the sum of the squares from group 3. So that gives us 46. Now we need to calculate the sum of the squares between. Okay, so why is there a 5 at the beginning of all these?
Five sets of data for each group.
Yeah, exactly. 1, 2, 3, 4, 5. So why is it 3 minus 4? Well, 3 is our individual average. And 4 is our grand average. Just like 2 is our individual average, our individual group average, and 4 remains our group average. 7 is our other group average. 4. So we get our sum of the squares between is 70. So we know our sum of the squares within. We know our sum of the squares between. We just need to know our and now we can add it up. The sum of the squares total. That's taking each observation and subtracting out the grand average. So how many observations do we have here?
15.
Yes. Guys are cold. Just because it's cold morning, guys are.
No, it's a subject matter.
It's the subject matter. I'm sorry. I know this stuff is really dry. Well, I brought you coffee. I guess I should have given you the coffee before that. Yeah, I can't make this stuff more exciting. It's just crunching through the numbers. I'm sorry. So the sum of the squares of the total is the sum of the squares between plus the sum of the squares within, which should sort of make intuitive sense. And if I felt like really belaboring the point, I would derive why that is. And I'd put all of you to sleep. Okay, so how do we calculate the degrees of freedom? The degrees of freedom between is what? 2, because it's the number of groups minus 1. And then the degrees of freedom within is the total number of observations minus the total number of categories, or the total number of groups here. So since you were kind enough to look in your F table, what's our F critical?
What's numerator? 3? 15? Oh, I'm sorry. 2. 2 over 12?
Yep.
For 05, it's 4.7, no, 3.89.
Yeah.
3.88.
So just by doing the division, we get our F test to be 9.13. Okay, this is an example of a left skewed, right skewed, or symmetric distribution, the F distribution.
Right.
Right skewed, yep. And in all of your hypothesis type questions, I always recommend that you draw a picture kind of like this, where you identify what your HO region is and what your HA region is. So the HA region here, that's the blue shaded region, your HO region is the white region. So where does 9.13 end up?
Fail. Reject.
We end up very much in the HA region. That's why drawing the picture makes it pretty easy to figure out, am I going with HO or HA? If I'm in the shaded region, going with HO. If I'm in the white region, I'm going to stay with HA. Because the double negative of failing to reject is always confusing. Just stay with HO, HA. Draw the picture, and it makes it line out. And why is that? Because what is our critical value define? Our critical value defines the extent of the variation that's likely to see from the extent of the variation that's unlikely to see. So it's the probability as observing a value as extreme or more extreme than that is that. I didn't actually get your scantrons from you, so we can't do this because I can give you enough scantrons. All right. Okay. So that's ANOVA in a nutshell. It's not particularly difficult. It's just straight arithmetic. It's not even algebra. It's just plug and chug. As you can see, it's fairly straightforward to do the math, but it's really easy to goof up, and they take forever. So if you were to see an ANOVA table on the exam, skip it. Remembering that basically every question on the exam is worth the same amount. In my book, that would be one of the it would be one of the questions that I know how to answer, but it's going to take forever, and I'll come back to it if I have extra time at the end. In all likelihood, you won't have extra time. You've gotten a sense of how tight time crunch you're going to be on this exam. So ANOVA, be familiar that it is a hypothesis test for 2 or more means. It's really powerful because of that. You can have as many samples as you want, as many groups as you want, and be able to say, is there a statistically significant difference between these guys? But for that power, you give up the ability to determine directionality. And often you do need to tell if it's greater than or less than, and ANOVA can't tell you that. But what you generally do is kind of use it as a screening filter, as if there is a statistically significant difference, then you drop down to do a 2-sample t-test. And then that gives you the directionality, but you use ANOVA as your filter. So if it's statistically significant, okay, this is statistically significant, this treatment is different than my control, and the difference is statistically significant, therefore I'll then do a subsequent analysis on it. Okay, now into regression. So what is regression? Regression tries to represent a mathematical equation to predict a response, an independent variable, as a function of dependent variables. So this is the middle school math concept of y equals mx plus b, where or ax plus b, depending on where you learned it, where m or b as it's written up on this b1 as it's written up on the slide represents the slope, so the rise over the run, and b or b0 on the slide represents the intercept of what? What's b represent?
One axis 0.
Yeah, the intercept of the vertical axis, generally y. The one new thing that we're introducing here is e, our error term. So when you did this in middle school or high school math, the line always went through the points. Unfortunately, in real life, that doesn't really happen. So that's the new attribute that we're adding. So you'll call this a simple linear regression, and the way you calculate this ordinary least squares regression has a couple of different names. So what is it trying to do? Well, we have our y-intercept and our slope, which is just the rise over the run. But we're introducing this error term, and we're assuming the error term follows a normal distribution. So it's some sort of normal random variable with mean 0 and a standard deviation of, we don't know. How do we go about not knowing? Well, sorry, that comes from our gauge R&R, so we understand what the sources of our variation are due to our measurement system. And remembering in our gauge R&R, we're trying to partition the sources of our variance into 3 buckets. What are the 3 buckets in gauge R&R?
Parts, operator, and gauge.
Yes. And the nifty little term for the gauge variability is the?
Repeatability.
Yes. And the one for the people is?
Reproducibility.
Yes. You're ready for the exam. You better get a good score on next week's exam. Cool. Okay, so correlation analysis. So if we're only interested in if there is a relationship, we can do a correlation analysis. So plotting a scatter diagram. If the observations go up and to the right, they're positively correlated. If they go down and to the right, they're negatively correlated. The closer the points are to a straight line, the closer they are to 1. So the correlation coefficient, rho, also written as r, is between -1 and 1. Can't be any value different than that. And between any set of points, there is always a correlation value. So how do you calculate this thing? You don't. It's a pain in the butt. But we should all be familiar in how to use our calculator to do it. Everyone figured out how to do linear regression on the TI-36X Pro? Okay, just to be clear, just make sure everyone does it, knows how to do it. So you put your data into L1 and L2. So hit data, type in your data into L1 and L2, then quit out of that. Then what do you do? Once you put your data in, what do you do?
Stats, LR.
Yeah, your data is probably still in there from when we did the midterm. Or the 2/3 term in this case. You can have your own.
I don't want to.
Yeah,
And mine
okay,
fixed.
well, use whatever use whatever you're going to use on the exam, but
Thank you.
yep. And yes, I'm going to sit awkwardly up here until everyone has actually done it on their calculator without me telling them.
What data do we use?
Any data, whatever.
We'll just use it.
Yeah, I use the midterm data.
So then we're gonna go to stats, number 4, linear regression.
That's it. What's it asking? Regression equals f at x.
Oh, that will allow you to store the function that's derived, the linear equation.
Oh,
So you can then use it to calculate out what your independent variable is to do a prediction.
How do you recall that?
I would have to go look at it.
I'll figure it out.
Yeah,
But
it's
that's good.
Yep.
Good to know.
So. So our X data should be 1, Y data 2, delta.
I don't know. I'm just the guy who stands up here and asks questions.
This one here should just be S.
whatever you put for y is choose it. It's two.
Calculating. Divide by 0 here.
And then is it calling A the slope?
Yeah. X plus B. My new favorite hobby is to watch the YouTube videos at double speed with the sound off and just watch myself gesticulate. It's really kind of funny. Particularly when it's something like this, when I'm waiting for you to do something. There's one where I actually moonwalk, which is really kind of funny. Okay, have we figured out how to get rho from our calculator? Row your boat. Down the stream. Hey, someone's watching live. Hello, live watching person. If you use the participation link, we can chat.
Brandon is almost the perfect fit. Positive.
We had data in there.
It's got good data.
That's actually from the exam.
Getting your perfect data.
I did. That was actually the exam data. Cool. Okay, so let's get back cracking. Okay, so that's rho. little r. And basically what it's doing is it's taking each individual x value, subtracting the average x value, multiplying it by each individual y, subtracting the average y. You can see the math is ridiculous. But this goes from being a throw-it-away question on the exam to type in 5, 10 numbers, hit a couple buttons on your calculator, and you're guaranteed to get the right answer. 17 bucks. Okay, so you can do a hypothesis test to say, is that statistically significant? So what's your null hypothesis? Well, rho is 0, that there is no relationship between these variables. You want to prove that there is a statistically significant difference between your variables. So your test statistic has a pretty easy formula once you've calculated rho. It's just rho times the square root of n minus 2 over the square root of 1 minus r squared. And we'll meet r squared in the next slide. R squared is really important. So this is actually kind of powerful. Another way you can evaluate the strength of your model is what? What hypothesis test do we know that we can use with regression? Good exam question. Good exam question. So what type of hypothesis test can we use to determine how good our regression equation is? Use the decision tree.
Just look at the answer all the time.
What?
Just look at the answer and you know all the time. Is the regression significant? Yes or no?
That doesn't actually that doesn't quite get you. Well, if it did an ANOVA test on it, that's one way of doing it. But there's a hypothesis test within our body of knowledge that we've gone over that is what you actually use more frequently for saying how well does my regression equation describe what I observed. Yes, chi-squared. Chi-squared is goodness of fit. How well does my data follow what I expected to see? So your expectation for chi-squared is the result of your prediction from your linear equation. So it's your independent value. Then your observed value is what you actually observe.
Or residual. Ah.
Yeah, if you remember.
Okay.
The equation for chi-squared statistic is observed minus expected squared over expected, and you add them up. So your observed is what you observed. What you expect is the result of your linear equation, or whatever equation, linear in this case. So you know you observed, you know what you expect to see, you know what you expect to see, you add them up, and you do the chi-squared test. It's actually kind of useful.
So that's x over minus e is y, right?
Yeah.
Or O is y. E is expected.
No, observed is what you actually observe when you actually go out and measure stuff.
Okay.
Expected is y. Expected is y. And yeah.
What's the t in your?
This thing?
Yeah.
It's your t-test.
How about the p? Is it?
That's rho. It's rho.
Thank you.
Rho. For some reason, I felt like being Greek. I personally, when I write it, I make it write it as rho because I don't want to get it confused with r squared. But,
Sure.
unfortunately, on this slide, I use both in the same slide.
I learned something.
That's the point, right? That's why you're paying the big bucks to come listen to me every Saturday morning, right? It's not to see me dance around.
Okay, so the
It's not for the sandwiches.
R square on the bottom is,
Rho and P, R and P are the same thing. Just one's the rho and one's
but then the R square now.
R squared is just the squared value.
Of
R,
rho.
yeah.
Okay. You're starting to confuse me when you just said it.
I apologize. It should be consistent and make it either rho or R. So how are these coefficients determined? It's by determining a line that minimizes the residual. So it's the least squares of the regression line. It minimizes the sum of the square differences between the points of the line. So what we want to do is we want to find the line indicated in red that has the smallest residual. So the smallest difference between what we observe and what the true value is. And we remember that the difference between what we predict and what we observed is the residual. This calculation makes the ANOVA calculation look straightforward and easy. If you ever take a algorithm design class, this is your first homework assignment, is to code a linear regression algorithm for whatever language you're in. It's not fun. That's why it's such a great investment. For $17, buying the calculator, you're good to go. Okay, so how do we assess the quality of our model? The math will always produce a straight line, even if there's no actual relationship between the two. So there will always be a slope, there'll always be an intercept, just because the math is just crunching numbers. So to assess how well it fits the data, we have to look at the sum of the squared errors. And the sum of the squared errors has a formula. So it's the number of observations minus 1, the degrees of freedom. We're sort of familiar with that. And then we have our respective standard errors. Not much fun. Likewise, we can do a hypothesis test for the slope. So our null hypothesis in the case of a hypothesis test for slopes is that our slope is 0. And we want to prove that there is a slope, a statistically significant slope between our data. Also indicated on the slide is also important that if there's no relationship between our variables, our slope will be 0. We can also develop confidence intervals for the slope. So Minitab is very nice, and most other statistical analysis software will give you the confidence interval estimators for your linear regression. So it'll be plus or minus 2 standard errors. So 95% confidence interval. Okay, now for something that is important, that you will be expected to be tested on, coefficient of determination, R squared. So it's physically the square of the correlation coefficient, so rho or R. What the coefficient of determination does is it explains what % of the variation in Y is explained by X, which is really important. It's always a value between 0 and 1, 0% to 100%. Your best possible model is that 100% of the variation in Y is explained by your X's. So if you tell me X, I can absolutely predict a value for Y. So there's generally a relationship between height and weight. It's a pretty strong relationship, generally about 0.7. So if you tell me your height, I can predict your weight about 70% of the variation that I would expect to see in your weight. So I have a pretty good guess about how much you're going to weigh if you tell me how tall you are. And r squared is 1 minus the sum of the squares of the error minus the total sum of the squares. So how do we get these respective values? Well, it's each individual y minus our average y squared. And the sum of squares of the error is, well, what we predicted minus what we actually observed squared. And why are we squaring it? To get rid of the negative signs. Or we could just scroll down to that option on our calculator where it says rho and then rho squared and just read the number. But the important takeaway is that r squared defines how strong a correlation there is between my variables. And said another way is, what percent of the variation in y is explained by x? So when we were at our baseball arbitration, we were arguing that over 70% of the player's salary in arbitration for a position player was explained by his home run total. So if you told me his home run total, I can tell you how much the guy should make. And it turns out the coefficient of determination, r squared for that, is about 73%. So we said to the arbitrators that, look, we have a pretty strong correlation, it's 73%. Based upon his 14 home run totals, he should make this amount of money. And they bought it up until the finals when we lost to Canadians. We lost in a baseball competition to Canadians. We can't even hold our own pastime. Very upset about that. But I get to compete against the University of Ottawa in Oxford, so as long as we beat them, I'll be happy. Okay, so that's regression. So now we can go into other thing that you should be able to do in regression. Let's go back to where we have the equation. So on the exam, if they give you a equation, you should be able to substitute in for an x and get a y. Kind of basic high school math. You should be able to use your calculator to determine the respective coefficients. So what the slope is, what the intercept is. Also for the exam, you should be prepared. It'll be a free question if you get it, is they might ask you to do something other than linear regression. Your calculator will also do exponential regression and a couple other options. They'll do polynomial regressions as well. They're almost impossible to do by hand. Well, not impossible, they're just very tedious to do by hand. However, if you scroll down past linear regression, you'll see that your calculator does those. So if they ask you a question on it, it's technically in the body of knowledge. They're so difficult to do by hand, I doubt they would ask you one, but they get it. Free question because you just put the data in, you go scroll down, hit enter, and you still evaluate it the same ways. So you still evaluate the quality of the regression that's resulted if it's a higher order regression based upon r squared. Because in that case, you're still trying to determine what percent of the variation in the independent variable is explained by what percent of the variation in the dependent variable is explained by the independent variables. Where the x is independent and the y is dependent on what the value of x is. So you just be familiar that there are other nonlinear regressions. Your calculator will calculate them out. You interpret them in much the same way as you do with linear regression. The math just becomes a little bit more complicated to determine what the best fit line is for it. And things like Excel do a nice job of fitting the equation to it. Everyone's used Excel and put the equation on the fit a line to it and show them the r squared. For some reason, some people didn't realize that Excel has that feature built into it.
What did chi-square test again?
Chi-squared is goodness of fit. So how well does my data follow my model? So in this case, my model is that it was linear regressed. So my expected value is the result, the predicted value, the dependent variable from my linear regression. So it would be the y in y equals mx plus b.
So how close that comes to a straight line?
Well, no. What you're doing is what the linear equation is giving you is a prediction of what you should observe. If you give me an x value, I predict that my y value should be this. And then what this is doing is this is comparing that your predicted value, your expected value, to what you actually observe.
Your y is 1. I see.
So the point there is that how good is my model? Am I observing a large number of values very far away from what I expected to see? If that's true, I probably have a pretty crummy model. Where if my observed and expected are pretty close to each other, I probably have a pretty good model. And what the chi-square test does as well, you have a standardized way of evaluating how big is big and how important is important based upon your sample size and your degrees of freedom and all those good things that we talked about when we skimmed over the chi-square test. But when it comes to calculations, it's the easiest to calculate. It's just observe, unsuspected, unexpected. Remember on the midterm, we saw an example of chi-square when it was the defect rate for the one plant in one state and another state, and they gave us the defect rate for multiple plants. And then we had to use chi-square to say, is there a difference? So then you just had to subtract over what you expected. Or there was a uniform distribution question where it was, we assume that everything follows a uniform distribution. We got this data. Is there enough data to suggest that it doesn't follow the uniform distribution? Right. That's a question on the midterm, right? Or making up. Yes.
Do you see that on a Minitab output for
Yeah.
regression?
Yep.
What's it? It says chi-square.
I think it does. I'll have to check.
You see others, the press and the RSM.
I don't know.
And
I honestly, when I don't,
it
I'm not,
seems
a
very
huge,
useful.
I'm not a huge fan of Minitab's regression suite. That I just said that on video, and it provides some of my conference funding. I think it's a little clunky on certain things, but I complain about features, and they occasionally listen. I really have a problem with the way they do process capability, and that you can't select the data that goes into process capability, so you can't do rational subgroups within your process capability without putting it in a separate sheet, which drives me nuts. On every one of the other tools in Minitab, you can select your data. So you can select a subset of your data inside the chart that you're creating, except for process capability. They don't enable the data button for process capability. And it's really frustrating because generally what I find myself doing with process capability is looking at the differences between different factors. So we have our overall process capability based on all 5 of our production lines. And I want to look at each one of our individual production lines to see, hey, is our capability the same across the lines? And to do that, I have to put each one of our data sets on separate sheets, which is kind of clunky. But they don't. They say, thank you, Brandon. Go back. We'll add it to the list of features for Minitab 25 or some version we have in the future. But I'm not sure if Minitab shows you the chi-square statistic. It's one of a plurality of tools that you can use for evaluation, but it tends to be the one I like the most because it's doing exactly what you expect. It's taking the observed minus the expected. And it's sort of a uniform approach. It's the same way you would approach if you're looking at how well does my data follow a given distribution. So you use the chi-square test to say, does my data follow the normal distribution, the chi-square distribution? That'd be kind of cool to use your chi-square test to see if your data follows chi-square distribution. Okay, so multivariable tools. So factor analysis is used to describe the variability among observed and correlated variables in terms of potentially lower number of unobserved variable factors. Then there's principal component analysis, which does some nifty transformations to look at the correlation between variables. Then there's the cluster analysis that's actually pretty useful, where it looks at how your values clump around each other. Then there's discriminant analysis, which is based upon the combinations of the interval variables. And then there's MANOVA, the multiple variable version of ANOVA. So we have factor analysis. So the purpose of factor analysis is to reduce the number of variables. So we want to figure out what variables are important, what variables are not. It's sort of a theme that we'll be going through today. Is we start with a lot of ideas, a lot of potential X's to study, a lot of potential independent variables to study, and we can't study all of them. And we want to figure out which ones are important. So in developing a predictive model for baseball pitcher salaries, started out with about 30 factors of different things: ERA, walks, innings pitched themselves, batting average allowed, batting average on balls in play, etc. And then whittled it down to about 3 factors that actually were statistically significant. There's something akin to a factor analysis and some understanding of the underlying baseball. So what factor analysis is a applied structure to reducing the number of X's that you're evaluating, where X's are the independent variables, the factors. the things that you're going to change in your design of experiments. A lot of definitions, sorry. Then we have our principal component analysis. So the principal component analysis is similar, very similar to the factor analysis, but it's more of an incremental step that gets you to identifying what your key X's are. These again are broken out in a bit of detail in your book. I think actually they might have I took out some of the slides related to these because on the new body of knowledge, you're the first class, the new body of knowledge, they de-emphasized this and they might have even taken it out. I just want to make sure that you had some basis in it if a question snuck in there. So the cluster analysis is generally done by eyeballing it. So you look at how your data is together and you say, there's a cluster. And try to understand why these observations are grouping together. So you observe that they're grouping together, and then you try to investigate what sort of unknown property is causing them to group together. Then we have the discriminant analysis. And in the discriminant analysis, you know why the data should be grouping. You have some understanding of what the underlying process is, what the underlying phenomenon is that you're studying, and you want to determine who's in the group and who's out of the group. That's kind of the reverse of the cluster analysis. So you have your predefined clusters. You want to say, how does this result in being in the cluster, out of the cluster? That's the discriminant analysis. Okay, then we have multiple ANOVA. Is used under the same circumstances as ANOVA, but you're looking at multiple dependent variables. So you're not just looking at the temperature, but you're also looking at the total dissolved solids. Okay, so those are just other ways of figuring out what are your important variables. What are the important factors that you should be spending your time and resources on? Okay, now we're up to stuff that's actually really useful, but they took it out of the body of knowledge. And I don't think they should have taken it out of the body of knowledge. I actually think they should have emphasized it more in the body of knowledge. So attribute regression. Anyone remember what an attribute is as compared to a continuous variable? What's an attribute?
Yes, no.
Yeah, yes, no is an example.
Newark, Princeton versus Trenton and Camden.
Yep. Yeah, any categorization of data, any nominal characterization that doesn't have numerical significance. Also, our attribute regression also handles the case of ordinal data as well. Remembering that nominal data is when you group things into categories with no numerical relationship. Ordinal data is the case where you put things into order. So first, second, third, fourth, Likert scales, I strongly agree, I somewhat agree, neutral, etc. So in the case of ordinal data, there is some sort of numerical relationship, but it's not numerical in the sense of 5 is to 6. And strangely, they took this out of the body of knowledge. And it's kind of this type, a lot of the data that you actually get to work with tends to be of this type, or at least incorporates attributes of it. So the math is extremely complicated, and you would have software do the regression for you, but you, again, have to determine which one to do. So the first is binary logistic regression. It's used for Bernoulli type variables. So Bernoulli type variables are what? Yeah, defects. So a Bernoulli variable is a specific type of variable that it can either take one of two states. It either is pass, fail, it's heads, tails, conforming, non-conforming, which is the same definition as a defective, right? So it's stuff that's based upon binomial distribution. So then we have nominal logistic regression, which is used for 3 or more categories with no natural ordering. So that's the Newark, Camden, Trenton example. Then there's ordinal logistic regression. So ordinal logistic regression, as it has the name ordinal in there, tends to be used for ordinal type data. So why are these additional techniques needed? Well, if we were to treat our non-continuous data as continuous, we get problems. All our linear equations just don't work. So if our response is support privatizing Social Security, it's either they support it or they don't. And if we want to look at that as a function of income, it doesn't work. Because the regression techniques for continuous data don't work for an ordinal type response. Likewise, without some major manipulations, the linear regression and the regression type approaches have challenges dealing with ordinal or nominal inputs. So if you're to look at salary as a function of education, college degree is yes, no. You either have it or you don't. Some of the regression techniques would struggle on that. So, conclusions about regression. What regression allows you to do is make predictions about a system. So if you tell me the x's, the independent variables, the factors I can control, I can make a prediction about my dependent variable. That's the response. That's the y. So tell me x, I'm trying to predict y. So they're composed of factors. Those are the independent variables. And responses, those are the dependent variables. So the independent variables are the factors. Starbucks, Dunkin' Donuts. Milk, black. Calf, decaf. Linear regression is the most common. There are other mathematical regressions for continuous data, exponential, polynomial, power, all of which your calculator will do. The calculations are somewhat complicated, most likely beyond the scope of what you'd see on the exam. But what's nice is if it is on the exam, your calculator will crunch it through for you. In the case of attribute data, you need to handle it differently. You can't use the same approaches that you can use for continuous data for attribute data. And there are approaches for that. There's different regression techniques. They took them out of the body of knowledge, so you don't need to worry about them, but know they exist.
Are they in the Minitab?
Yes, they are.
Is this a special category?
Yes, it is.
What's it called? Oh, never mind.
No, I actually have Minitab up.
Wow.
That's really annoying. I can't do that. Sorry.
Too high.
Yeah, it's too high. Sorry, we're having minor projector problems. Regression.
Non-linear.
Yep. So we have nominal, ordinal, binary logistic, bit of binary.
Wow.
Yep.
Good stuff.
Yeah. Full disclosure, some of my conference funding does come from Minitab. They will be funding my conference talk at the Lean and Six Sigma conference on March 2nd. I'm taking a day trip to Phoenix.
You see the price of that?
Yeah,
Oh my God.
they're all, yeah. Yes,
Plus hotel?
yes. And it's at a golf resort too. It's not even in Phoenix. This is my third or fourth time speaking at this conference. It's an okay conference. It's just really expensive, and you're not in Phoenix. You're up in you're about a half an hour from Phoenix, so it's kind of.
Every course to add on.
Oh yeah, well, it's a money-making endeavor. So
Wow.
it's an okay conference. It's a little disjointed, in my opinion. The annual conference is worth going to. If you haven't been to, it's worth going to one of those.
The which one?
The annual, the International Conference on Quality and Improvement, whatever ASQ's annual conference is called, the full name of it. It's in Nashville this year. Unfortunately, I'm speaking at two conferences in Nashville a month apart. It's like, wait, come on, guys. Can I go somewhere nice? Some people get to go to conferences in San Diego, Hawaii. I get Nashville. And unfortunately, the way my schedule is working out, I'm doing a day trip to Phoenix. I'm flying out. I land at like 11 o'clock local time. I'm speaking, and then I'm taking the red eye home.
Oh no.
Yeah. It's like,
You get comped when you speak?
Minitab gives me a $500 travel stipend.
Big deal.
Airfare.
Airfare, rental car, and a meal.
Wow.
And some of them, actually, the airfare and the hotel and this nonsense becomes over 500 and end up losing a little bit of money. But it's fine. I was doing them out of my own pocket before that, so the fact that I now get it sponsored is like, okay, yeah.
Sure.
I'm kind of like the race car guy who races on weekends, and it's like when he finally gets a sponsor, it's like, yes, I'm not paying out of pocket, but I'm not making any money, so it's fine. Okay, let's play with some coffee. Let's play with coffee. Come on, come on, come on. Coffee, coffee, coffee. Everyone likes to play with coffee. I might be the only person who likes to play with coffee. You're not going to miss anything. So, has everyone had coffee from Dunkin' Donuts or Starbucks before?
Sure. Yes.
I hope so. It's always awkward when people haven't. It just happened to me a couple times. So, prefer Dunkin' Donuts or Starbucks? Okay, so we're just got to split.
Well, raw coffee, Dunkin' Donuts, mixed,
Mixed with what?
espresso, something.
Okay, yeah, well, we're doing regular drip coffee. Okay, so a little bit about how coffee's made, right? How's coffee made? Anyone know?
Bean, roast, grind.
Yeah, okay, so coffee grows as a plant, right? It grows in tropical climates. The only place that actually grows coffee natively in the US is Hawaii. Kona coffee actually tastes really good. There's some grown in Puerto Rico, but it's not exactly what it is. And actually I have a coffee plant that grows in my condo, and it actually produces fruit, and it's not supposed to fruit in captivity, particularly if you're growing in a pot, like on your windowsill, and for some reason my coffee plants has decided to produce fruit. So you have a coffee plant that produces a cherry. The cherry is then picked, it's then dried, ideally, slowly, commercially, very quickly in these big commercial dryers. It's then dried and roasted, and then once it's roasted, it then gets shipped around the world. In some cases, or in the case of Starbucks, it's dried and then shipped around the world and roasted locally. This Starbucks is roasted in New York, Pennsylvania. Yep. I don't know anything about Dunkin' Donuts distribution. So the bean comes in as a whole bean. It's ground. It's put into a paper filter. Then it's made in the drip process. So water is heated up. The water is actually boiled. It's then put through a condenser. The water condenses at roughly 200 degrees, drips through the coffee, drips through the filter, and drips into the carafe.
What about roasting?
Lots
of room for variability.
There's lots of room for variability, but Starbucks uses a very large batch size, and their QEs, who I've met two of, their entire existence is to make sure that every roast is exactly the same.
Wow.
And their batch sizes are so huge that it eats up a lot of that variability. Because the roasting is it's basically a function of temperature and the other stuff that's in the room. So, yeah.
It's about time too.
Well, time. It's like cooking anything. So, if you cook it at a lower temperature for longer, you get different results than you do at a high temperature for a shorter period of time. Okay, so you have to break the tie. Starbucks or Dunkin' Donuts?
We used to work at Dunkin' Donuts and eating.
Okay. Well, actually, that's kind of an interesting difference. It's one of the differences that we can talk about is Starbucks are Seattle-owned for the most part. Dunkin' Donuts are exclusively franchised. There are no Dunkin' Donuts brand stores in the United States. There are about 7,000 Starbucks-owned stores in the U.S. So your daughter didn't work at Dunkin' Donuts. You worked at franchisee Dunkin' Donuts. But if you worked at Starbucks, you actually worked for Starbucks. Okay.
But they have to buy everything from.
Correct. And full disclosure, my cousin is Chief Licensing and Trademark Counsel for Dunkin' Donuts.
Wow.
Oh, absolutely. I just feel compelled to disclose that I do have a relationship with Dunkin' Donuts. So her work tends to be on why, if you go to these Dunkin' Donuts in New Brunswick, you get a Giants Cup during football season, and in Trenton, you get an Eagles Cup. their licensing agreement is within a certain number of miles from the stadium. It's the team that's affiliated with them in that 90. And the Jets, no one likes the Jets. Yeah, no one likes the Jets. But it's funny because one of her common complaints is someone will call up and an executive from one of the teams will go. It actually generally happens in DC, where one of the executives for the Redskins will go and accidentally get a Ravens cup and will flip out and call her. Okay. So, Dunkin', Starbucks. Do you agree that they taste the same? Okay, so what is taste?
Subjective.
Well, there's different components to taste, right? Right, there's 5 components to taste. Nah, it's not that much, of course. It's not very bad. So, what is coffee? We've all had coffee before. What is it?
Coffee beans, roasted, ground.
Okay, but what's the brown liquid?
Brown stuff.
It's brown stuff.
Yeah.
It's brown stuff. Yes, yes. That's actually the way I generally order my coffee when they ask me, which roast do I want? I generally say, can I have the brown and hot one? And occasionally I'll get a blank stare until they realize I'm trying to be funny, and then we'll have another thing put in my drink. And then they realize that, oh, you just want coffee. Okay. So what coffee is it's a suspension of organic molecules in water. Not many of them, it's actually mostly water. It's about 5 little C calories, not kilocalories, 5 little C calories, basically nothing. So the taste that you taste is a function of how much coffee is in your coffee, how much of the beans. So the more coffee there is actually in your coffee, the richer the taste. Seems kind of reasonable, right? The more stuff there is, the more stuff for you to taste. So that represents the total dissolved solids, which is basically the amount of non-water in your water. Technically, the number of charged ions, which is proportional to the amount of non-water in your coffee. So I think we can measure that. Just intuitively, which one do you think has a higher total dissolved solids? Starbucks or Dunkin' Donuts? Okay, why? Because it's got a.
For me, for taste, I would just have to add too much other stuff.
Okay, it's got too intensive a flavor.
Right.
So we expect there to be a higher total dissolved solids in Starbucks as compared to Dunkin' Donuts. What about the effect of decaf? Do we expect there to be a higher total dissolved solids in decaf as compared to regular? Okay.
I took something else, so maybe less, I don't know, maybe room for more, I don't know.
Also, what do you think will be the effect on the total dissolved solids of putting these contaminants in?
Palatable.
Well, it'll make it palatable, but do we expect the total dissolved solids to go up or down?
Is that
Well, no, the solids,
It's
the coffee
Oh,
solids
what's milk? Is it water? I would hope it's got a lot of water in it, but it's got a lot of other fats and
Yep.
nutrients and things that are very good for raising a cow.
It's not conductive. It's not, doesn't ionize.
well, that's, usually the milk and that, the additive is cold, so
Well, it's
the brew has already been done.
Well, it's absolutely going to decrease the temperature. So that's one of the factors that we're going to, one of the responses we're going to look at. So that's a reasonable supposition. So we don't know how putting the milk is going to affect the coffee. You can make an argument that we're putting more non-water into our water, so there's going to be more fat, and our total dissolved solid should go up. But there's a good question of if it fully ionizes or if the meter is going to be able to detect. Okay, so we sort of have some hypotheses. Kind of neat.
Well, wait, that's calcium, right?
Yep.
Calcium makes hard water, and TDS goes through the roof. Yes.
Lots of different ways to argue it. We're not quite sure.
Because we have hard water.
Okay, so it's a reasonable experiment, right? So we're consumers. We want to determine if Starbucks tastes the same as Dunkin' Donuts. We also want to see what the effect is of decaf versus regular. And some people contaminate their coffee.
Actually,
Make
like you
better.
said, as far as the water, what is the difference from,
Well, the
were these
water,
both bought from the same,
They were bought from stores 2 blocks from each other in New Brunswick. They were bought at the same time, both this morning. And yes, I had to go to one store, but they were within the time it took me to walk from one to the other and pick it up. I called ahead. Okay, so how do we?
both chlorinated water?
Could be filtration.
Okay, it could be difference in the filtrations.
The equipment used to brew it.
Yeah, actually they both use the same brewer. Brewers made by the same company.
wow,
Yeah, I don't know about the filters. I know that Starbucks gets their filters from a company in Montvale, New Jersey. Montvale, New Jersey. What? Montvale, the one in Morris County. It's a big client. Okay,
Lots of variables.
lots of variables.
What's the temperature setting on the brewery?
Well, coffee has to be between 200 and 210. It won't brew if it's between that. You'll just get water if it's below that, and above that, you'll get really bad coffee.
What's the calibration on it?
what's the mechanism in brew? Water passes over the grind and then,
Yeah, so what happens is the water gets boiled. It then condenses, it cools as it rises up through the drip coffee maker. As it condenses, it happens to condense at about 200 degrees Fahrenheit. It then drips through the coffee, thus drip coffee. Since it's hot and through osmosis, the minerals diffuse into the pure water because it was just boiled off. So the water picks it up. It then passes through the relatively coarse paper filter, taking off any of the big contaminants. And then what just left is the suspension of the coffee grinds in your coffee. And if you're like me and you've occasionally forgotten a cup of coffee on the windowsill and all the water evaporates out, you're like, wow, there really was a lot of coffee in my coffee. Has anyone done that besides me?
sure, find a cup.
Okay, I just want to make sure I didn't incriminate myself yet again. Also, we're talking about drip coffees here. There are other brewing technologies. French press makes a really good cup of coffee. We've had that. And Starbucks has a Clover technology, the Clover machine, which works as an inverted French press that uses a vacuum to suck the coffee through a Micron mesh filter, and it makes the smoothest cup of coffee you'll ever have. And it's only about a 30-cent upcharge, so it's absolutely worth it. It's actually an interesting story. It was developed by 2 Stanford engineers that were doing their PhD and were always looking for a better cup of coffee. So they were tinkering in their garage and came up with a better way of making coffee. So they started selling it in the greater Seattle area, the greater Northern California, Pacific Northwest. And how, as the folklore goes, Howard Schultz, the CEO of Starbucks, was wandering around the store in San Francisco, saw this really long line in front of a coffee shop, and Howard Schultz is sort of infamous for saying that he wants everyone to be drinking Starbucks coffee every time, everywhere. So he gets in line and waits in line and sees this kind of wonky homemade looking machine making their coffee, and he tries it and he falls in love. And he asked the owner where it came from. The owner gives him the 2 Stanford guys who literally made this thing in the garage, and he calls him up and says he wants to buy it. And they basically refuse to take his call. And Starbucks calls and offers you a considerable amount of money for the thing you tinkered in your garage. You're generally going to take it. But these guys were selling onesie twosies, and they're selling the Clover coffee machine for about 10 grand. They actually sold about 300 of them. There's 300 of them in the wild. As the guys started to develop it and realize how hard it is to sell a coffee maker at $10,000, they started to realize it's a limited market, and they're more guys who like to tinker in their garage. They don't like to run a business. So when Howard Schultz then kept calling, he took his call, and eventually Starbucks ended up acquiring Clover, the company that the Stanford guys came up with. But they had the intelligence and the wherewithal. In their negotiated contract, Starbucks has agreed to provide service and parts for the 300 or so Clover machines they had sold prior to Starbucks making the acquisition. And now, occasionally, those 300 machines get resold, and Starbucks actively bids for them.
Wow.
So they'll go on eBay, the restaurant will close that have the Clover machine, and Starbucks will be bidding against everyone else because they don't want them to be competing against it. So right now, the Clover's machines used to sell new for about 10 grand. The used ones that Starbucks doesn't control go for about 15 grand. And they make a really good cup of coffee. Starbucks in New Brunswick has one. What towns are you guys from? Remind me. Warren, your star doesn't have it. Sorry.
Basking Ridge.
Aspen Ridge doesn't. Somerset does. And you are?
Sparta,
Sparta. I don't know my Starbucks all
Yeah.
up there.
there's no Starbucks.
Yeah, there's no Starbucks up there. Mars County and that area is sort of weak in that Starbucks. Marstown, which you're passing away, theirs does.
Somerset stores. Easton Ave?
It's off of Easton. It's on the road that runs parallel to Easton. That's escaping me. And I always drive past it. Okay.
Not M1.
No, it's not M1. Okay. So, how do we set up our experiment here? We have coffee. We have milk. We have cups. We have meters. What do we do?
DOE, design experiment.
Okay.
Categorical factors. 3.
Okay, so how many factors do we have?
3.
We have 3 factors, right? How many levels do we have?
2.
2 for each, right? So stored, D&D, Starbucks. Contamination, contaminated, not contaminated. Caffeination, we have calf, decaf. And we can do all of our permutations, right? So we have decaf Starbucks, we have decaf Dunkin' Donuts. We can add the milk to whatever we want.
Where's the sugar?
That's a 4th factor.
Come on, the sugar register somewhere.
4th factor.
Where's the sugar?
Salt.
Where's the sugar? That's for all the sugar. How do I do the sugar?
Oh, they have some milk, yeah.
Up there.
Oh, but then there's a rat poison.
Oh, subgroups.
Okay, so do you want to study the effect of contaminating with this?
The chemical versus the natural.
Yeah, the rat poison.
How do you want to do it? Come on. What do you want to do? What do you want to do?
We're going to come up with a huge number.
Well, how many runs do we need to do? If we're just going to do the 3 factors at 2 levels, how many runs do we have to do?
2 cubed.
2 to the 8th, right? But do we want to do any repetitions?
Sure. We have 3 built in, 4 replicates built in, right, already? We each sample.
Oh, do we have replicants or repetitions?
Combination.
Depends on the
We
structure.
should have individuals.
Well, when we get to our design, when we get to lesson 10, if you read ahead, those had very particular meanings. So replications are complete reruns of the entire experiment. So we would have to go and get more Starbucks, more Dunkin' Donuts, redo everything. Repetitions are repeated measurements of the same things. So in this case, it's a fairly reasonable supposition to say that these are homogeneous liquids. So if we sample from it right now, we sample from it right after it, it's going to be the same liquid that we're sampling. But if we were to get it tomorrow, it would be reasonable to say, yeah, we're redoing the experiment. So what we could do here is we could do multiple repetitions, but without going out and getting more coffee, we couldn't do replications.
Tasting's not a response.
Tasting's not a response, no, because it's subjective. But one of the other things that I'd like to look at is cost, right? So which do you think costs more?
Starbucks.
Or you had to think of Starbucks? We'll just talk about the coffee traveler, just because the large coffees are different sizes. The Starbucks coffee traveler was $14.95. The Dunkin' Donuts is $15.95.
No way.
What happened to 999?
Wow. Same volume.
Yep, same volume. It's actually the same patent. They're actually sourcing it from the same supplier.
Capitalizing on an illusion, on perception.
Yeah.
Must be less.
Yep. Okay, so the Starbucks actually was cheaper by $1. And they're purchased from the same store, same geographic area, subject to the same local taxation. Okay. So what's going to be our experimental methodology? Do we have cups?
We have 8 cups.
We have lots of cups. We should have like 20.
TDS.
Now are all the cups got that
Wood-
plastic
Yeah, they're all-
lining in it.
Yeah, they're all pretty much the same cups.
So what you design? You made your design, you have the worksheet?
Oh, no, I just, I just used Minitab to, we'll use that to do our cube plot.
Okay.
But, Minitab is also randomizing it. So it randomized the order which we did the experiments, but that just happened to be me just putting it up there because we wanted to ask another question related to Minitab. So, but we have to proceduralize it. So we're gonna fill the entire cup up?
Enough to measure.
Okay. Do you think it matters how much coffee we put in here?
It shouldn't have long as they're
For
mixed.
temperature, I don't know.
Okay,
Temperature's gonna cool down.
it's gonna cool down. It's gonna measure pretty quickly. But what about adding the milk? So these guys are, how much milk should we put in?
You can't accurately dispense that. It's either all or nothing.
Yeah, it's either all or none. So
Drop.
so we're gonna add one of these guys in for our milk. Okay, but then does it matter how much coffee was in there in the first place?
Yes.
Yeah. So I need to kind of figure out how to do that or eyeball it. What do you think?
Straw, like a pipette. Eyedropper, you have none? Weight.
We can do it by weight. If we want to, I can go run to my car and grab a scale, which I actually do have one in my car. It's out of my hands.
Can you see the markings on the outside of the cup? If there's liquid in it?
That's such a small amount.
Well, I'm just, no, you can't, in other words, like, you can't see the line through. Well, you can, but only if it's held up to the light, which then.
Well, you have a straw, right?
So that's-
You can mark the straw and stick the straw in and fill to the line in the straw. That seems kind of reasonable. Okay. What other problems could we have? Well, these have been sitting here cooling off since we got here, so they've been sitting off for an hour. So we expect those to be kind of cooler just because they've been hanging out. How about it? Do you think you need something to rinse the meter off with? Kind of like a water to rinse off with?
What's the
Sure,
meter?
contaminate, we have individual meters. Measurement system analysis of the meter. R&R.
Oh, do you want to do? We have 4 meters. So you want to do 2 meters to see how the meters change? That's probably a good idea. So we have this guy. Hopefully they all turn on, since I use these like twice a year. Yeah, they turned on.
And so what's the meter testing?
Well, the meter is going to give you the parts per million and the temperature.
Then maybe the.
And generally,
How far do you,
if we had more time,
meter.
if we had more time, we'd actually do multiple meters. I have a cheaper total dissolved solid meter, and we do pH, but we kind of correct for time, so I want to cut this down a little bit.
the depth in the coffee cup
Well, you just need to
should
cover,
be.
yeah, you just need to be able to cover the electrode. It doesn't really matter, so you need to have yay-ish.
Okay. So then the procedure of stirring in the milk has to be good.
I told me, hold on, you guys do realize you're getting up and doing this, right? You're gonna have to get up out of your seats and like stand up and dance, and you'll be on film. Well, on whatever the digital equivalent of film is. Have fun.
Jane, the dancing machine.
So we need the table.
Oh, that's right there.
No. You don't get to use the Minitab yet. It's mine.
So
We
just,
need
we were talking about determining whether Starbucks tastes different than Dunkin' Donuts, but I mean, we're
no,
measuring
it's
something.
for temperature and size.
Yeah, we're doing total
During-
dissolved
right,
solids.
Got it,
We're just looking at it in that. If we had
Right.
more time, we'd be also doing pH, which would give us the acidity.
right.
It turns out when you do the difference in the pH, there isn't a difference. And through lots of experimentation, I've determined that pH is more a function of where you get your water from. So if you well versus reservoir will give you a statistically significant difference in pH. That's one of the things since I've done this enough. So I did a comparison of espresso shots between New Brunswick and West Caldwell, New Jersey. And it turned out that was the difference, was the municipal water supply.
We're gonna
It's that the
have
water going in inherently had a different rheology, and based upon that, it propagated out to the ultimate coffee, and it affected the pH such that it was noticeable.
coffee doesn't overwhelm it?
No,
Make it-
no, because the majority of the coffee, no, because coffee is only marginally acidic, believe it or not. It's not as strong as an acid as you would think.
Wait a minute, you have to parallel what he has.
Oh, yeah, like the run
I'm
orders.
just trying to,
The run order's not
Different.
super. The run order's not super.
No, it's
So
the
then we're gonna
design,
have-
right? You got
Yeah,
Two
well, this is,
stores.
the only difference is that this is randomized.
two
Don't worry about
levels,
randomization.
okay.
so then we're
Everything's
gonna
two
have to have,
levels. Right, second, ready?
and then we're gonna do what, 4,
Yes,
black 1, 2, 3, and 4. And then we're gonna have,
milk.
we're not gonna add the sugars, or are we?
Up to you. I would say not.
No,
Yeah,
no,
okay.
that-
Um,
we're not gonna have that many samples.
where's the eraser? Oops.
Oh, you're right.
Yeah. Thank you.
Wait, we're going astray here. We've got to follow the design.
No, we don't have to follow the
We're
design.
gonna end up with 16 samples.
Oh, okay, because we're doing repetitions. There's no repetitions up here.
No, within, we're doing like one at a time versus.
And then you got,
Oh, we can do whatever we want.
so these runs and these runs should take place at the same time. Black.
Okay, so we need to reset up the design then.
1, 2, 4. So this would be time. Time 1, let's say. And then you got regular.
Different
So we
cups.
need
We do.
to do the black first, and then we'll do a setup for,
Or you can,
now we're gonna do 4 different individual pourings for, one does,
no, we're all the same. You can do it as a progression. Do it black and then add the milk.
Right. it's like the-
Well, do you want them to be independent or do you want them to be a function of each other? Because you probably just want them, one of the assumptions of ANOVA, which was what we'll be using, is that each step was independent. So you really don't want to,
that's why I separated them here. But,
We have enough supplies we have enough resources to run this experiment?
well, for the regular, we have lots. For the decaps, not totally close.
oh, I didn't even put decaf up here yet, so that one will,
So these
yeah.
little guys are
So
individual.
decaf will just, should we be doing 4 or 2 for decaf? And then milk and not milk. Yeah, black, and then what we can do is over here decaf. And this will be high test.
Okay, so if we're doing 3 factors, 2 levels each, and we're doing 4 replications, how many samples do we need? How many runs do we need?
Three factors, 2 levels, by what?
4 replications, 4 repetitions.
8:32?
We have 32
Yeah.
cups, or we have a problem.
Progressively add.
Well,
Eight.
the problem is if we go progressive, we violate our independence assumption. How many cups do we have?
Yeah, we don't have 32.
Do we have 24?
Yeah, 24.
Okay, so let's do 24. Let's do three.
So we're on.
One,
the
two, one, two,
D-
three.
Okay.
Oh,
We're
okay.
only gonna do 3 repetitions. Everyone two slides is 24, right?
What?
Why we end up with 24 data points?
So we got 24 cups.
Yeah.
Oh, no, because we're
Three
full.
runs, right. We had
But wait a
32 with
second,
4
hold on a
runs.
second. These cup, all right. Yeah, but, okay, I'm
That
just,
doesn't influence the measurement.
No, as long as there's enough liquid in there. We have to make sure that we're more or less the same with the when we add the milk, but it'll be close enough.
all right, so somebody has to mark, put an indicator, take one of my Post-its and wrap it around the,
Flag, depth gauge.
there's the blue ones. So figure out how much you're gonna put in, make sure it's gonna be deep enough so that the,
Measuring
just gonna
device.
go in.
How much does the device need?
that's,
How does this come off? Twist or
Yeah,
pull?
twist. It's kind of a twist and pull.
So it needs at least the probe covered, right?
Yep. And the probe is going to displace some liquid, so it really doesn't need that much.
so they go higher, go a little higher. Or you just,
This much?
That's perfect.
Can we
Wait,
spare
that's-
that much?
Yeah, we can probably spare that much.
For the regular, sure.
Yeah, for the regulars, we've got
Plenty.
48
is that gonna
ounces.
stay in place?
No.
It's not?
Well,
It's not super critical. You can just take a marker and mark it.
yeah.
But then we may get marker in there.
You're not going to drink it.
You think it's gonna stay?
No.
Let's
So-
put a marker
For
in.
one, it'll stay for one.
All right,
Stapler?
Yeah, let's do this. I think that's gonna come
which means put on my glasses.
Or you can just eyeball it. It's not.
out. Yeah, it's not.
It's not super critical.
Okay,
You wanna start?
I gotta
We're,
mix
we're not trying to publish these results.
okay, so we're doing the regular,
Dunkin'
the high
Donuts.
test coffee, oops, this.
Right,
this
so
permanent?
Dunkin' Donuts.
Yeah, we
Nope,
got
they're all dry erase.
Okay.
The one thing is that the red just doesn't show up. If you can write in the black, the camera puts it the black a little bit better.
we've got to watch how many we pour out because the temperature will, we should do them.
We should do one at a time.
Yeah, I'll do it one at a time.
So who's gonna go first? Mix the, actually, why don't we do a Dunkin' and a Starbucks first, one person.
Then you need 2 meters at once,
We have
right?
2 meters. We have lots of meters.
Okay.
Just talking
So
about using a temperature. So,
let's put the decafs to the side. You gotta mix, shake these up, because they've been sitting.
What block are we doing first?
We're doing, somebody's gonna do, black Starbucks, and somebody's gonna do black Dunkin' Donuts at the same
it
time.
just makes sense to go through one. I mean, because we're gonna do it pretty quickly.
But then the temperature, well,
Yeah,
You're
it's
gonna
gotta
do
be
them really
within-
quickly,
Gotta be
so it's not
within
gonna be-
3
but this
or 4
way
minutes.
here, he can pour, you can pour, and then done.
Who's going to measure? Brandon?
I can't
No,
play.
you guys are measuring.
I
You're
just,
gonna pour, put it down,
Perform-
measure.
Performing it.
I
pouring
just
it.
drink the coffee and stand here and
Okay.
dance.
All right, why don't we want to do the,
So who's doing Dunkin', who's
I'll
doing
do
Starbucks?
Dunkin'.
All right, maybe you wanna give yourself more table room? I know you spread all the cups out. So you're gonna do a sample of 4 for now. Or 3, rather.
3.
So you got 3 cups, and you got 3 cups.
What are you doing?
You have to do 3.
3
Oh.
Starbucks.
No, you're doing 3 Dunkins, he's doing 3 Starbucks.
There was a reason there was Dunkin' cups.
Okay.
The experimental design has been ruined.
There we go. There we go. So you have-
Okay, why can't you see the logic that was there?
Come on, let's get through the storming phase of the Tuckman cycle. Let's get to the performance stage.
Okay.
You shook it, you stirred it.
It's amazing how
Yeah,
fast we got through
I shook
the,
this.
Why don't we help?
That's fine. It'll work together. Probably could have poured this into it.
Okay, so we have
Okay.
quick measure.
I'll just quick.
just make sure the meter is set to read in ppm and temperature. There's a couple different modes you can go to. And then it's on.
ppm and degrees C.
Yep, that's perfect. Fine. Just make sure we're all degrees C so I don't have to convert.
Degrees F.
So what's the temperature of the first one?
117. Right, or total, no, sorry. I'm reading your PPMs.
How long does this need to,
It's
instantaneous?
more or less.
So PPM is 110.
It's going to bounce around. So you're going to have
Just
to
say 110.
and just make sure that the times.
Temperature?
Is there
Underneath it?
49.6 Celsius?
It's actually pretty warm.
So we
Okay. Sample two?
put both meters.
Yeah, just quick.
Okay, sample 2 is 104 ppm at 50.7.
What sort of agreement? Close?
They're close.
Okay.
Sample three?
I just want
Just use
to use the same meter.
yeah, just use the same meter.
102 is ppm.
I thought it expedited using it.
51.1.
51.1?
Yeah.
Okay, let's do the Starbucks.
Okay, so two still the same.
And I guess maybe we can now pour those together.
Yeah, you can condense this. Just try not to make a mess. As someone that always ends up wearing their coffee, I can.
I just don't want them to spill it.
Yep.
All right, Starbucks. 135 ppm. Oops, no, it's coming down. It's a second. Okay, 112, 105 ppm, 49.8. Okay, sample 2. Let's give it a second to settle. 88 ppm at 53.4. Sample 3. 81 ppm and 54.6.
Now what?
Okay,
Duncan?
now we get to do the add milk ones.
Okay.
So put these together. Give one to Brandon.
Oh, what I get?
Just the same drill, just have to say one milk container.
Yeah, one container of milk.
Okay.
Now, question is, do we want to put the milk in first? And then add the coffee?
What the hell kind of design of experiment is this? I don't know either. I'm confused.
I show up.
These assistants are no good in the lab. Out.
Okay,
I just show up and get in the way.
so pour your coffee's ready.
Let's, we'll keep it simple, pour the coffee, then we'll,
Pour, stir.
then we gotta stir.
Why don't we open
Where's
these
this data go?
underneath? Regular.
Temperature? Regular?
The same readings.
Oh, regular means with milk?
Yes,
Right.
Why didn't you use the same sample?
Well, no, because then there would be.
because it's cool. So let's get
So
3 of these ready. Scratch that one. Splash.
Okay.
Just be careful to make sure that the times 10 is not eliminated.
Yeah.
On the meter, there's a little times 10 that pops up on the ppm.
No. This is NaCl.
Yeah, no, when it's giving them, they're approximately here on the meter, it'll flash up times 10 if it's
Okay.
if it's adding an extra decimal point.
Okay.
Just a heads up. I'm not sure if it did, but
Okay. says times 10,
It's
flashes up, yeah. I think,
So we're
okay.
pouring
Yep, you're ready.
coffee gun.
Yep, then we're gonna add milk. Which one gets the milk?
Creamer and stir.
All get milk, right?
Yeah, just one. It's still coming down. So yeah, it's times 10. Okay, 12.4 and 46 degrees Celsius. So we'll just have to divide those by 10.
Oh.
Yeah.
12.4?
well,
We'll just add a decimal point for right. Turn off.
it's times 10, so it's 124.
You
So
want
it's 1240.
1240?
Yeah. And the other ones
Oh.
were
Yeah, I got you,
add an extra zero on everything.
Gotcha.
Yeah.
Okay, 1140 and 48 degrees Celsius. 1130 and 48.2 degrees Celsius.
40,
48.2. I like you saying Celsius.
they know what to say.
Yeah, right.
Are these all gonna next week?
Yeah.
sugar?
No, we're not
No,
doing
no,
sugar. We decided no sugar.
So we're combining?
Yeah, just
Yeah, you can, yeah, just so you don't spill them. Or you can drink it.
Depending what you measure glass with the meter.
these meters have only been used to measure coffee.
Okay. Starbucks.
It's kind of neat. I can do the same activity with high schoolers, middle schoolers, and adults. It's great.
The empties, prepare the.
Ross makes fun of me. He calls this my middle school science class. You say, are you doing your middle school science class today? Yes, I'm doing my middle school science class today. The alternative was I could just give you the data and we could have me walking through the ANOVA slide again. It's a little bit more fun, right?
You can smell the difference in the coffee when he's pouring it.
So maybe you have to filter difference.
You should do this with Coke and Pepsi.
You using the same meter now,
Yes.
or you cross contaminated?
You should be washing them off in between, but it's such a trace amount.
It's still coming down. 1360 and 46 degrees. $12.50 and 48. $1,249.
Let's keep going.
Now you get to do the decaf.
Fortunately, if we want to repeat one of these, we have enough coffee to probably do it.
I'm gonna sacrifice a cup here.
You could have drank out the one that was in.
It's kind of funny. I've had groups where
Why?
You may want to use it for something else.
I've had groups that have been so afraid of drinking the coffee once a probe is.
Oh,
in.
huge,
Yeah, right.
huge difference.
But I've
Yeah,
had
too. Yeah.
I've had classes where they've like refused to go anywhere near the coffee after a probe has been in it. You guys are like, yeah, whatever.
What do we need?
Let's do the Dunkin'.
You had something that was hot.
Decaf, right? There we go.
Somebody still.
Decaf is here.
You know what?
Yeah, right, this is.
That's-
okay.
The cups have the decaf. I used to get decaf travelers and those
You're
are-
gonna take, yeah, you're gonna have to take that lid off.
yeah, just be
Yeah.
careful pouring it.
Oh, Mike,
Oh, there we go.
this isn't gonna work.
Yeah, hold it up for you.
This is going all over, better the carpet than the table, I think.
That's good.
More? Good?
That's good.
Okay.
Slightly above what I'm. Good. So we're doing, yeah, just solid. Fourteen, 20, and 36. 1,400 and 36.4.
13 what? Straight
36.4,
36.4.
1380 and 36.8.
That's interesting.
Okay, yeah, so we're gonna add milk, right?
To the Duncan?
No, now we're doing the high test, the Starbucks decaf.
What's the little sword for?
It's the stopper. It stops you from spilling coffee out.
No kidding.
Yep.
Thoughtful.
And they also make really good shoe toys.
Okay, we lost it.
Huh.
Do we get-
Just
Okay,
be careful pouring that to make sure the lid doesn't pop off on you.
good, just going up to that line there.
I can't see.
Okay, good.
Good?
Yeah.
Okay.
Yeah, I'll call it out for you. All
Oh,
right,
it's poured
good.
well.
That's good.
This cup is better thought out.
Actually, the contour of the cup is designed for a
Good.
cappuccino to
Okay.
ensure that you have a proper milk foam ratio. That's why it has a particular capers test.
Uh-oh. This one's dirty.
No napkins?
ppm and degree C.
You need napkins?
No, they didn't.
Oh. Let me go run out and get some napkins.
Okay, it's 1,631.4, 1560 and 32.3,
1560?
correct, and 32.3. And 1540 and 32.7.
Was
32.7. Okay, so now,
Let's add your bovine lactations.
Duncan?
let's get
It's gonna have to be-
Yeah, we have creamers in here.
Yeah, the cream machine's back.
Three and
Yeah.
three for the next set.
Little more. Okay. All right.
Too much?
That's all right. Just slightly above. All right, good. Down, so just gonna- Okay, 1780 and 31. $1730 and 32.4. Okay, 1690 and 33.4. Okay.
get your creamers ready. Oh, they're here.
That's right. All right, ready? Ready. Good. All right, good. So far, good. Get this down.
You guys get the feedback forms will be sent out to the class next week, at the end of next week's class, and you can comment on this lesson if you feel like it.
1810 and 29.7. 1820 and 30. 1790 and 30.
Okay, so now that we have our complete data set, do we want to redo any of these? We'll probably use the
Lower,
same.
higher? Not so much lower, higher?
Well, orders of magnitude, we're in the thousands-ish
Yeah,
everywhere besides these two guys.
Starbucks?
I think it might be worth redoing this.
Sure.
But now
The
time
meters,
the temperature reading. See how close the temperature is. I'll write it in red next to it.
Oh, we can give you brown.
let's give the meters a switch. We have clean cups,
Uh,
two.
we got two.
All right.
Yeah, these, yeah.
I kind of look,
Yeah.
because all our other measurements are in the 1,000 range, and those are
Yeah.
the lowest.
Is there blue?
No.
No, they didn't need
So
another.
probably only need to do this.
Well, no, you should do all
No,
three.
we'll redo all three. We can reuse one cup.
Yeah.
Here we go.
to sync.
Oh, here we go. It's empty cup.
Okay.
And yes, you can actually drink the coffee, and I hope you do.
Oh, I didn't open my thermos yet, so.
Okay, well, we might have to track you down a cup, though, since we used all of our cups.
I still have mine.
Okay.
Okay.
Where'd your partner go? Where'd he go?
Probably the restroom, I assume.
Or did he go get more cups?
I don't know. Where'd he go?
Or clean some cups, I don't know.
Oh, start with Starbucks, we got it.
Oh, we found cups.
Oh, okay.
Oh, cup run. Okay, so
Cup,
we'll
cup,
do
cup, cup. Cup, 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 cup.
Perfect.
There's 2 meters at once in
Yeah,
case
I don't know.
something's off.
Well, the
No,
meters were pretty
no.
consistent when you put them in, so.
Yeah, you should.
We may have mixed the meters up initially, maybe that's
Yeah,
why.
let's just,
Yeah, let's just stick with one. And
yeah, stick with
Yeah.
the same one. One less variable.
ppm degrees C.
do that.
So we're just doing it on
Yeah, we just because those
plain vanilla one, not the.
yeah, those just looked strange because they were just orders of magnitude.
A little bit, huh? Okay.
All right. It started out at like 1,800, now it's down to 1,312. Just give me a second, I want to let it settle.
Yep.
That's probably something else, another variable we should make after 15 seconds. Okay, 1,147.6.
That sounds better.
Oh, wait, oh,
Yeah,
okay, hold
1,147.6.
on.
10, 50, and 50 degrees. 50.
That sounds better.
Yeah, it's still trending down now.
It's a function of temperature.
Yeah.
But yeah.
990 and 51.
That's more.
Okay.
More. Yeah. Okay.
So we have to take an average for these.
I don't know. We'll cross that bridge in a bit.
Okay, so now we have,
Because that was about 10 minutes later.
Yeah, but our temperatures are pretty close. If you look at them across, they drop to about 2 degrees.
2, 3.
Yeah.
4. Well, 2, 4.
Okay, now drink the coffee. Actually, make yourself a cup of coffee and chill out, and now we'll start to use this stuff.
Maybe the regular milk versus this.
Oh,
creamer.
this is cream.
Oh. Well, just
Just pour yourself some
yeah,
fresh.
take it, just pour one of these in one of those and catch it. Whoops.
Guys,
cup.
at least it's $20, $28.
Yeah, it's not cheap, but I think it's important for you guys to go through the exercise of actually experimenting, getting the data, and realize how variable the data is, how hard it is to read the instrument, that the numbers going to jump around, and that's going to introduce source variation. Because when we talked about repeatability and reproducibility, we talked about like how can you misread a gauge, and how can a different operator read?
I did it.
That's okay. How can a different operator read a different measurement? Particularly as it relates to total dissolved solids, a different operator would have gotten a different reading than you just because they would have picked a different point. They would have let it sit for a different amount of time. They would have just picked a different number. And that's where the repeatability and reproducibility come in. And that's sort of why I think it's important to go through the exercise of actually collecting some data and playing with the damn data.
Yeah.
It's not just I like to play with coffee. I like to play with food. But there is a reason. There's a method to my madness. I'm just not mad. It doesn't preclude the possibility that I am in fact mad, but there's a method to my madness. So we'll come back to our data in a bit. Oh, she didn't have to go. We'll clean up the table at the end.
Why does it have a bitter kick? It smells nicer.
Yeah. It could just be the particular region which the beans are sourced from. I didn't look at where they were brewing from today. I was kind of annoyed. I talked to the manager last night when I left and said, "Can you leave a note saying I need one of these at 7 a.m.?" And I walk in at 7 a.m. and there was no note. It was no big deal, but unfortunately the manager who was on last night, I'm pretty good friends with, and I get to give her a hard time now.
Yeah.
You get used to it.
We're getting paper
I don't know
towels.
what my discount is. I think they still sell. I don't know about that model. They still sell financial.
No.
Yeah, they still sell.
There's only hand dryers
Only
in the
for
restroom.
model.
It's like a little rectangle brick.
I haven't even, yeah, I should have,
Well, it's gonna be
I had
fun
one at graduate school and I loved it. It was,
getting this.
financial stuff.
I had the one with the card reader.
We'll make everything. We'll make everything sure.
Programs the way I love that.
Nice.
It's jammed up.
Yeah. I didn't even,
You'll have
I
plenty
never
of
saw
microwave.
We made that.
Nah, it actually gets dumped.
Interesting.
Or you can bring it home with you.
Cool, yeah.
Now.
Creature, yeah.
Somebody probably somewhere.
Like a tractor, yeah.
People fix old HPs?
No, but if you have working ones, they go for good money on eBay.
Ooh, that $400 one you had.
I had one that had a magnetic card reader.
That's pretty cool.
But it jams, it's useless.
It's a pro, like, is that?
Oh,
Yeah, I love my TI-89.
$400
But
back in 1973.
yeah, I personally love my TI-89 titanium, but it's not allowed in this exam. And it's fully programmable. But the TI-36X Pro, as you saw through the exam, it does a really good job of what you need for this
Yeah,
exam.
what do you need it for, right?
It's pretty much does everything you need for StatsLand.
Mhm.
The TI-89 actually will actually do the t-test for you. We'll do a NOVA for you. But
What's that, like 80 bucks or so?
it's a little bit more than, I don't know. I know when I got it, it was a lot more than that. It's probably come down in price since when I.
Yeah, I saw some other options when I tried this.
Yeah. My understanding of the calculator policy is pretty much anything above this is out of scope.
Yeah.
Because as soon as you can program it or do numeric entry, it's not allowed.
Yeah, they said something on the thing about no alpha. Now, we do have,
You can just do X, Y, and Z, but they don't count as alpha.
so these,
A to
Oh, those are other variable names, but like on the TI-83, you can use it as you can put words in there. You can say sentences. And if you were an engineering student here during my era, you put the goddamn chapter notes into your calculator and had every freaking formula programmed into your calculator. I know I did it. I know I'm admitting to cheating on an exam on tape, but I know every one of my classmates did
it
it.
wasn't cheating. I mean, it's
No,
using your resource.
it flat out was. It was no different than us writing the formulas on a sheet of paper. We just put it into our calculator. It was a dumb requirement that you couldn't have a formula sheet.
Yeah.
Particularly when the hard part was not memorizing the formula, it was doing the manipulations on the formula, knowing what formula to apply, but that's...
Some exams they would let you bring in a script sheet, but then people would write it so small. I was going
Yeah.
to class to read it.
Yeah, I'm a firm believer that everything should be open book, open notes, because the exam should be structured in a way that it's testing your ability to apply the material.
And
And
that's how it's going to be the work.
Yeah. And I think that's just a better representation of the skills that you need and what you should really value. But they don't ask me. But fortunately, the ASQ exam is open book, open notes. You can bring anything you want as long as it's not the work exams. So as I joke, you can bring a holy book. I had one person that brought a dictionary from their native language to English just because it just made it easier for them.
Which meant the prof couldn't tell if there were questions and answers in that.
No, I was talking about the ASQ. I was talking about the ASQ, the green belt, black belt, CQE stuff. Cool, thank you.
We'll stay there, just move it on.
Well, I was gonna.
Can you imagine the extra time that would take to look up
Well,
what is?
I think it was just a matter of there were some nuanced words that didn't quite translate perfectly. And as you can see, some of these questions can hinge on your understanding of a particular word. So I think it was just a crutch for them. They just wanted to know that it was there. But if bringing a little stuffed animal to sit on your desk is going to help you get through the exam because you can pet it, and as long as you don't bring a magic 8-ball.
Answer.
I think they might consider a magic 8-ball to be cheating. I don't know, but okay. That'll take too much desk space. So now we're actually going to go through our design of experiment stuff, then we'll loop back and actually use your data. But based upon what's up there, do we think there's a difference? Our factors matter? So what about the difference between the total dissolved solids between CAF and decaf?
Big difference.
Very different stuff.
Yeah, decaf has a much higher total dissolved solids. What about the effect of milk versus not milk? Did adding milk cause us to go up in our total dissolved solids?
A little bit, but not as bad.
I went from like 1,500 to 1,800, from like 1,000 to 1,300, from like 1,400 to like 1,700.
Right, so you have to.
So in the decaf.
I was just reading off
Yeah.
one, and
This
it's only in the one that we didn't really go up as much. In our regular D&D, regular Duncan. So it looks like things changed, right?
Yep.
So we'll see if those changes are statistically significant in a bit. Okay, so the idea in Six Sigma in general is you start out in the define phase and you have lots of ideas, lots of potential possibilities. And what you're using your brainstorming techniques, those are the affinity diagrams, the force field analysis, the Ishikawa fishbone diagram, the work breakdown structure, all those tools we talked about in our first week, you're trying to get up as many possible ideas as possible. All the things that could possibly influence your process. All of the things you might want to analyze and control, improve, to look at. Those critical attributes that you think possibly maybe could affect your results, your output. Then we start to get into the analyze phase. What you're trying to do is you're trying to work down from all of these possible ideas down to a fewer list that you think are the ones that really make a difference, that have the biggest bang for their buck. So if I improve this, I will generate this result. So you've worked from those big ideas, you've narrowed it down. And we talked about a couple different ways to go through that narrowing. So in that narrowing, you can use the multi-voting just to reduce the ideas. But you can be more mathematical about it and use your hypothesis test and saying, hey, does this factor cause a change in my output? And is that output statistically significant? So you can use a two-sample t-test, right? You can run it with your before, after, is the change in the mean statistically significant? Or you can look at the change in the variation. So you can use the f-test to say, hey, did I reduce the variation by whatever factor I changed? And was that reduction in the variance or standard deviation statistically significant? So that brings us from the define, where we have lots of ideas, down to the analyze, where we use our hypothesis test to limit which factors make a difference. And then in the improve phase, we further whittle down the list to the factors that we think we can actually change and should be focused in on targeting the proper value so that we get the best possible results. And one of the ways we do this is with design of experiments. So when we talked about hypothesis testing, I tried to make a big point of saying that just because it's statistically significant doesn't mean it's actually significant. And I also wanted to make sure that you understand that just because in our regression we have variables that are correlated, it doesn't mean that that A causes B. Just because two things happen together doesn't mean that one variable causes the other. The only way we can determine causation is with design of experiments, where we have a very structured approach to determine if the change in our response is caused by our change in our independent variables. So if our dependent variable is really dependent on those independent factors that we've identified, or there's some other perhaps confounding factor that we weren't looking at. And then the final step in this filtering process is control. So when you get to control, you want to be keyed in on those 2 to 3 variables that you want to make sure that you are monitoring to make sure your process doesn't change. So those are generally your KPIs, your key process input variables. So those variables that are critical to the process success, and those are the things that you're going to monitor to make sure that your process doesn't slide back to where it was. Remembering that 70% of all continuous improvement projects fail. And one of the most common places it fails is in the control phase, when there's that handoff from the continuous improvement team to the process owners who will actually be living in that environment. So the idea is to start from as many ideas down to as few ideas that you're ultimately going to control.
Can you go back?
Yep.
What's XIA? Cause and effect and then XIA? The top one.
Yeah, using process maps and...
Do you have the rest of the slides that go with this? I've seen this called X-sifting.
I do, and I can't send them to you.
You can't share them?
Those I can't.
Oh, Brandon.
I can't. Those are internal Medtronic's work products. They get yelled at me when I send stuff like that.
Take the name off.
I can do that. I'll take a look and see if I can find it.
Thank you.
XIA. Good question. We'd have to look that one up.
This is the big problem area. The people at the top, people sit in the boardroom with gray suits and walnut and say, I know this, I know that, and you get attribute, and I feel. And then you get down at the bottom, the DOE, the actual fact, you may never get to that.
Yeah, and that's what the hard part is, and that's why the brainstorming tools are so important. And that's why the project scope is so important. And that's why the project charter is so important. And that's why, if you remember, there's the critical why that's identified right on your project charter. And the why is what you're going to measure. So once you've defined that, then you use all of the design of experiment tools and all the data analysis tools to figure out what causes a change in that why. So if you look through it through that lens, and that's sort of one of the focuses of Six Sigma, is to use data to get past the I feel, I think that stuff. And to say, look, I collected the data, I looked at the data, it was statistically significant, therefore, I don't care what you think. The data says something different. And to be able to relay that data using control charts, using hypothesis tests, using the results from design of experiments, to be able to say, okay, it's just not my opinion, I'm not interpreting the data, look, here's a picture. And have the picture really tell the story of your data and your data analysis. Remembering why Short came up with control charts in the first place was he was so frustrated about sitting in his office crunching these numbers all day long to go to his boss and say, I got a really cool result, and the boss says, what the hell is that? And the whole idea here is to be able to have your experiment, your data to tell a story. And the big difference with Six Sigma is that you can use that story to make a business change, that you can link it back to the dollars and cents, unless you're in Sweden. So the generalized design of experiments, the goal is to isolate the effect, so the change in the dependent variable, the output, that is a result of the change in the different inputs. the factors. So you also want to get an understanding of the interaction of effects. So how does milk interact with decaf? Is there any interaction to that? You also want to get a sense of the magnitude of your experimental error. So your experimental error includes all of your gauge R&R stuff. And we saw in our measurements here that reading the gauge is kind of as much of an art as a science as a guess. The number bounces around. Part of that is because the inherent measurement is a function of temperature. Some of it is that we're measuring indirectly the amount of total dissolved solids based upon the ionization. The correct way to do this is with a moisture analytical balance, where you were to pass the coffee through a filter with a known particle size, and then dry the filter and see how much mass it obtained. Moisture balances start at like 2 grand. Sorry, I don't have a 2 grand balance sitting in my back pocket. I have other cool toys, but that isn't one of my cool toys. And I tried doing it in a toaster oven, and I nearly lit my condo on fire. You have to, if you're putting in a paper into an oven and hoping the paper doesn't catch on fire. As you can imagine, it's a fine dance. And if you're impatient like me, you tend to keep upping the temperature until the paper catches on fire, and then you're screwed. Not that I tried this. Do not try that at home. And the goal of design of experiments is to get the biggest bang for your buck. So to get the maximum amount of information for a given effort. And the basic idea here is to expand the idea of ANOVA to many factors to determine what factors are important from ones that are not. That's sort of an inherent theme in Six Sigma, and all the stuff we've been covering for the last couple of weeks is to determine the critical few from the trivially many. And there's lots of terminology here. And the exam, as it relates to the design of experiments, is most likely going to ask you about the terms. The math becomes rather involved and rather intensive and takes a while. But the terms are important. So they'll most likely ask you about the terminology. So the response variable. So the response is simply the output, the measured thing that you're going to measure. So in this case, it was the total dissolved solids and the temperature. We also could have measured something like the pH. That also could have been a response. We also talked about the price. The price is a response. It's something that we could measure. So the factors, those are the inputs that we can change. So we changed the store. We changed if it was caffeinated or decaffeinated. We changed if we contaminated it with bovine lactations versus not contaminating it with bovine lactations. So those are the factors. The levels are the values that we set the factors to. So for store, we have the store factor has 2 levels, Starbucks, Dunkin' Donuts. The caffeination factor has 2 levels, caffeinated, decaffeinated. The contamination factor has 2 levels, milk, black. So response is the output, factors are the things you're going to change, they're the X, and the levels are the values that you set the factors to. So now we get into some more complicated terminology, and we have replications. So replications are complete reruns of the entire experiment. So if you're testing a cookie recipe, they're separate sheets of cookies. So I make a new batch of cookies, I put it in the oven. That's a replication. Whereas repetitions are the individual cookies on the sheet. Repetitions are repeated measurements of the same experiment. So here we had repetitions. We had 3 repetitions of each one of our measurements. We took the same batch of coffee, we measured it 3 times, thus 3 repetitions. If we wanted to do a replication, we would have to go get another batch of Starbucks coffee and another batch of Dunkin' Donuts coffee and repeat everything. The exam will try to trip you up on what's a repetition versus a replication. So however you can get it to work, the cookie sheet versus cookies analogy works for me. If the Starbucks example works, that's great. If you can come up with something else that works for you internally, that's even better. Okay, so that's replication and repetition. Then we have interaction. So interaction is how the factors interact with each other. So if we were trying to predict an individual's weight, and we wanted to do it as a function of gender and height, it would be likely that gender and height interact with each other, right? Or it seems, based upon our data, that there's some interaction between adding milk to the Dunkin' Donuts that's a little bit different than adding milk to the Starbucks. Not quite sure why, but. So interactions is seeing how your factors influence each other. So it's looking at the idea of synergy, perhaps, or a good example is with a catalyst. So if you add a catalyst to a reaction, it causes the reaction to occur. There's an interaction between the catalyst and whatever the other compound was to cause the reaction to happen. So that's interaction. So blocking is basically what we did up there. We actually did blocking. So blocking is the process where you de-randomize your data collection for a couple of different reasons. It could be to confound particular factors, or it just could be, as we did here, for the ease of experimenting. So blocking is the process where you restrict the randomization for some good reason. When I worked in American Standard, it would take us about 2 weeks to change the temperature of our kiln for it to stabilize from when we did temperature adjustment. Obviously, if we were looking at the response due to a change in the kiln, we couldn't be bouncing around the temperature completely randomly. So we'd have to block off all our factors for temperature, or associated temperature, at a particular level and run them together, just because it took 2 weeks for the kiln to reset. So blocking is some way that you restrict the randomization either for ease of experiment or if you want to confound your errors in a certain way. Then we have coding. Coding is the process of translating your data to make it easier to interpret or to understand. The most common way you see coding is to take the days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, and encode them 1 through 5. One of the reasons you do that is because there's an inherent numerical relationship between Monday, Tuesday, Wednesday, Thursday, and Friday. Right? Monday comes before Tuesday, comes before Wednesday. However, if you were to just forget that and you didn't code it, many data analysis softwares would just put them in alphabetical order and would consider the order that way, which isn't true. You're discounting the information that Monday comes before Tuesday, comes before Wednesday. But you're not losing any information by coding Monday is 1, Tuesday is 2. So coding is a process where you translate the data to make it easier to interpret, to understand, to do your data calculations. In patent land, it's very common to refer to an 8-digit patent number by its last 3 digits. So it's the 154 patent instead of the 876, whatever.
The truncating of a number.
Yeah, it can be truncating as long as you don't lose any information as a result of it. If in the process you're losing information, it's not an effective coding. But if it's just a one-for-one renaming, that's coding.
What about your Monday to Friday example, where you make it ordered?
Yeah, that's example coding, because there's inherently that property, and what you're doing is to ease your calculations and to force your data analysis software to recognize that property that was inherently there, you're coding it as 1, 2, 3, 4, 5. So you're not creating any new information, not losing any information. You are just renaming it to make it easier for the calculation to be performed. Just like if you were looking at a measurement that's 15.00007, and you're only considered with the 00007, you can leave the 15 off. Just like on the meter, it does the times 10. You just easily could have recoded the data just leaving off the last 10. In the case of leaving off the last 0, just make sure that when you're doing your calculations, it's not affected by that. So that's coding. So coding is any way you change the naming convention of your collected data that doesn't compromise the quality of the data collected. You don't lose any resolution, any precision. You've just made it easier to interpret, to understand, to process. That's coding. Then we have our noise factors. Those are the factors that it's impossible or expensive to control. Those are the things that are outside your control. You know they exist, and you're just going to model them in. So in the case of our Starbucks Dunkin' Donuts example, one of the noise factors would be the water filtration that the particular store is using. We have a pretty good suspicion that the filtration systems are different between Starbucks and Dunkin' Donuts, but we have no way of controlling that. Okay, now we have confounding. So confounding is something very common that you encounter. So confounding is the result of some sort of variable that's exogenous, cool word there, that is outside your model, that you're not controlling for, that you're not looking at, but that's really affecting your output. So confounding is something hidden that you're not seeing that is really influencing your results. Confounding is something that always scares you in design of experiments. That you're really not looking at what the underlying thing is, you're looking at the result that causes the result. Or in the case of the plastic manufacturer that I told you that had the material that's being lowered into the hot oil bath and they had to measure in gravity. Gravity was confounding their actual measurement because they had the gauges in peak mode. Okay, balanced design is setting each factor appears the same number of times of each and every other factor, what we had here. So each factor was measured the same number. In a sense, we have a non-balanced design because we redid our Starbucks measurement because we thought it was suspect. So full factorial design is you look at every possible combination of factors to perform a complete study of the interactions. So the exam loves to ask you questions like how many runs are required for this design of experiments circumstance with this number of replications and this number of repetitions. So to calculate out your runs, it's just the number of levels raised to the number of factors. Then for your repetitions, you just multiply it by the number of repetitions multiplied by the number of replications. Good?
Sorry,
Yep. So this gives you the number of runs.
Right.
If you're doing repetitions, you need to multiply the number of runs by the number of repetitions. If you're doing replications in addition, you need to multiply the number of replications by the number of repetitions by the number of runs, just to know how many actual cups of coffee you need to sample. Okay, then we have partial factorial design, which is a way of saving time and money by not doing every combination. So you just want to focus your resources and your time on doing the configurations of your experiment that you think are most interesting. And how you determine what's most interesting or most likely to gain a result, the result you want, is as much of an art as it is a science. And there's lots of different approaches to making sure that you have proper coverage without having to do a full factorial design. And it's really specific to what you're working on as to, do you think it's going to be a smooth type transition or a sharp transition? Is it going to not work, and then magically start working, or is it going to be a slow progression? So then there's partial factorial design, which is what I was just talking about, which is the idea that we're going to do less than all the possible combinations in order to try to approximate the overall effect without having to break the bank. Then there's Latin squares, which is used to, is a form of factorial design that looks at a particular set of points to make sure those particular points are covered. And there's probably a table hidden somewhere in your book on Latin squares. They're a pain in the neck to calculate. It's based upon the orthogonality of the matrices. If you ever get a grad degree in statistics, it's not much fun. Okay, so your typical data, this is actually real data, which I had to write a report to the FDA that I was not particularly proud of. So this is the main effects analysis. So this is looking at the response of fiber thickness as a function of donor, mill number, and mill speed. So what the main effects does is it looks at the change in the response that is due to various factors. So this guy is showing the change in the thickness of the fibers versus our donor. Our donor is actually coded. You'll notice 1-3, where they were longer numbers, the mill number, and the mill speed. So just seeing how the response changes as a function of those particular factors. Then we have an interaction effect analysis, which looks at how the factors interact with each other. Then my personal favorite, the cube plot. And we'll be generating a cube plot for the Starbucks data in a bit. So anyone seen a cube plot before? Okay. What a cube plot does is it's a three-dimensional representation of a three-factor, two-level design. So the exam loves to ask you questions about that are phrased sort of like this. A quality engineer has run a design of experiment and generated this type of, the following cube plot. The goal of the experiment was to minimize the fiber thickness. What configuration of factors should he use to get the smallest fibers? So how would we answer that question? So we want to get the smallest possible fiber size. What levels of our three factors should we use if we wanted to minimize our fiber thickness? So we have our three factors, right? We have donor, mill speed, and mill number.
Donor 3, mill speed 1, and mill number highest you can.
Okay, so we're looking for the smallest number here, right?
1290.
1290. Okay, so that corresponds to donor number 3, right? We're on the right side of the box. Okay, we're also on the top of the box, right?
Mhm.
So we're on mill number 155. And we're on the back of the box, so we're at the mill speed 1. That gets us to this point. So how do we interpret if the effects are statistically significant? Well, we're going to run ANOVA, and we're going to look at our p-values. And again, we're going to compare them to our level of significance, our level of significance generally being 0.05, unless there's a really good reason for us not to use 0.05. So we see that our linear regression, our linear is actually statistically significant. Okay, so why don't we take 10 now, and then we'll run through the data on Starbucks, and we'll keep going from there. Sound good? Then we'll go through our financial stuff pretty quickly, and then hopefully we'll have the last hour or so for questions, for review, since it's probably the only time we're going to have to review. So see you back here at 10:02. And please, please, please drink some more coffee.
Pour this in the garbage.
Yeah, you can clean up. I would. You might want to take the coffee to the bathroom and just dump it down.
Yeah, I didn't copy it. I didn't touch the book office before. Send you an email. Came in tonight. And send you an email. Yeah, I think we all have the same email.
I tried to put together a table, and stuff just gets confusing.
Oh yeah, it's designed to be confusing. But again, guys, please get together, study with yourselves. You've got lots of friends going through the same.
Is anybody drinking the, maybe we can use these to transport?
Sure. DMC.
Well,
So I gave you sandwiches. I gave you coffee.
Yeah. Good deal.
and knowledge.
Knowledge. Yeah.
Yeah, but you knew you were getting the knowledge when you signed up. You didn't know you were getting coffee and food.
But you made it taste better.
Yeah, I made it taste better. Exactly. I made it taste better.
What's with the CDs at Starbucks? They have some very nice mixes.
Yeah,
They're not
Starbucks has
really-
actually had an interesting evolution with music. So Starbucks had their business model is developed on the cafe culture, and there being a certain specialty about going there. And one of the things they're able to do is by setting that ambiance with music. And they started playing it sort of inherently, and people would go up and ask the baristas, like, what is that? And it happened so frequently that they started selling the music that they just happened to be playing sort of randomly. Then it grew way too big, and they started their own music label, Hear Music. And they had these really cool concept stores in the late 90s that I thought were really cool. They were basically music stores where there were Starbucks and music stores. So you could listen to music, throw your headphones on, and drink coffee. It was a really cool concept. I was at the one in San Antonio, but this was right during the death of CDs.
Yeah.
And it was the wrong time. Starbucks actually signed Paul McCartney was their record label, Hear Music.
Wow.
And they just threw a ton of money into it, and it was just too far afield from their core
Got
competency.
neat mixes.
Yeah, but right now what they're doing is they have distribution deals with a couple different companies. Actually, Lady Gaga distributed her most recent CD through Starbucks. And it's a really amazing retail proposition because so many people go in there. And it helps Starbucks average register receipts because their coffee sells for like $4 each. And by throwing a CD on there, it moves the register receipt up to like $20. So actually, as music retailers go, they're in the top 10 in the country, which is kind of scary.
Really?
Yeah, because they're, which is, it's an
I used to
interesting.
enjoy that. They had a ratty old couch. Some of them had a fireplace.
Yeah, some of them still have fireplaces. They still have the cafe culture. The chair has become an issue, particularly in the urban stores. And it's my local Starbucks in New Brunswick is currently struggling with this. Is you want to have it be an open community so people can hang out there and not chase people out. You can buy your coffee and hang out there all day and read and get your work done. But there's a balance, right? So there's certain individuals that abuse that and don't really buy anything and hang out there all day, and so paying customers can't actually get a seat.
Oh, really?
Yeah. So you see that like in the bathroom. So Starbucks has gone back and forth on a locked versus open bathroom policy, and it's pendulum swings one way, it swings back, it swings back, and there's no real good answer to it, because you want to have an open and free environment that people are happy to stay there and spend a lot of time there and spend a lot of money there. But on the other hand, the homeless populations, you don't want it to be a de facto homeless shelter, because if you have a critical number of those individuals populating your store, it's going to start scaring away your other customers. So where that sweet spot is, and how do you formulate a one-size-fits-all policy for 7,000 stores when it's such a localized issue? Yeah, it's really hard. The bathrooms are the really big tension point as well, is because the baristas are responsible for cleaning them, and they get really stupid things in them.
Yeah.
There's no other way to describe it. Like, they will defecate on the floor for no apparent reason. Like, why? So why aren't you just a normal human? Like, be a good human.
You don't want to know the story that a friend told
That's
me
funny.
who works at Macy's.
It's just be a good human. And if you're at the corporate level, if you're at a very large company like Starbucks, like how do your customers be good humans? Besides putting up a sign saying like, be a good human. Like, did we not make it out of like being a 3-year-old?
What about that other, some dichotomy or some irony? I don't know what it is. The poor area buying the most expensive coffee, yet they find the money for.
It depends, right? So Starbucks is actually at a really nice price point when it comes to being a luxury that you can kind of indulge yourself and feel like you're doing something nice for yourself with not breaking the bank. So if you're looking at the drip coffee, it's about $2. That's not a lot of money. And is it more expensive than you can make it at home? Yes. But you can feel special for that, for the waiting in line, for the 20 minutes you're in the store, you can feel like, yeah, I did something nice for myself. And even if you were to go out to a bar and get a beer or wine or whatever, you're going to be spending more money for that. And there's other externalities that are associated with that. You go to Starbucks, you spend your $2, you get to feel like you pampered yourself a little bit, and it only cost you $2. At the end of the day, you can probably think about 1,000 other ways you wasted $2 in that given day. So they're at a pretty good price point when it comes to that, because it's an indulgence, absolutely, but it's enough of a small indulgence that you can rationalize it. And even if you were to say cut out your $2 a day Starbucks habit and you go every day on your way to work for the entire year, you're not talking huge amounts of money. So it's
Mine was never $2.
Really, what do you get?
Well, because the other one tastes better, and
Okay. Well, if you play the game, if you subscribe to what they want to do and upcharge you,
and that muffin looks good too.
well, that's where they want to get your money from you. But
apple pie.
if you just go in there and get drip coffee, this guy is $1.98. So I'm not making it up. This guy's $1.98. In the month of January, it was even better, because if you spent $30 for their January mug, it was free for the month. That was actually really nice.
That a special mug?
Yeah, they do a holiday promotion almost every year, at least for the last 4 years. That if you buy the special mug, you get free coffee for the month.
These are here. I washed them out in case Your meters, do they need to be rinsed?
Oh, no, that should be okay.
I found in this thing, Brandon, this had It's really neat in color,
Ooh.
but there's a sample of that scatter.
Oh, the three-dimensional?
Yeah.
Yeah.
I
response
have a
surfaces?
zip if you want to take a
No,
look.
no. The response surfaces are really neat. Minitab does a cool job of them. I've yet to find a good example of how to actually, not to how to generate them, not how to make the pretty picture, but to actually have a situation where the pretty picture mattered. I put them in presentations just because, oh, this looks cool.
If you want, I have it on a zip.
Oh, no, I'm actually okay. But it's a cool, I'm certain there's an application for it. I just haven't found it yet. Where the surface response or the response surfaces are needed. They're really cool. They look really neat. And they make your computer spin around and
That's the holy grail, the torus. Run an experiment that generates an equation that produces a torus.
yeah.
It's like the holy grail. Look, search, never.
See this one and this one here, because all the dots are different colors.
Yeah.
You can see,
Yeah,
Really does.
except the whole point of what we're doing is to be able to use that to make better decisions and draw conclusions. And every time I've tried to do one of those cool things, it's been like, okay, that's really cool. What the hell what
do I do with it?
What do I do with it? I put it on the PowerPoint slide, so my boss thinks I actually did something cool. Okay, so let's actually play with our data. Okay, so let's go with the. Start
I'm
putting.
gonna add an extra line for the. How did you, oh, okay.
Minitab randomized them, so we're just gonna.
Oh, so you can't
Yeah,
sort them and then
I
write
could.
in the data and then.
I could, but we could just. So Dunkin' Donuts decaf milk. Do we have a
First one was 1780 for solids
1780?
at 31 degrees.
So Dunkin' Donuts decaf milk again.
1780, 31 degrees.
We have two of it's in.
Oh, no,
Yeah.
oh, you didn't say you wanted the
Oh,
second.
second one.
1731, 32.4.
Okay, the Starbucks regular black.
Starbucks. Regular black, this first or second run down?
First one.
1050, 49.8.
That one. Let's do the second one. Let's do the second observation of the first result.
The second run.
Yeah, second.
Okay, 1100, 47.6.
Okay. Dunkin' Donuts decaf black.
Black, 1420, 36 degrees.
Okay. Starbucks decaf milk.
1810, 29.7.
Okay. Dunkin' Donuts regular milk.
1240, 46 degrees.
Starbucks decaf milk.
1820, 30.
Okay. Starbucks regular milk.
1360, 46.
D&D regular milk.
1140, 48.
Dunkin' Donuts regular black.
1100, 49.6.
49.6. Starbucks decaf black.
1600, 31.4.
Dunkin' Donuts decaf milk.
1731, looks like 1690,
1690. Okay.
33.4.
Okay. So Starbucks regular black.
1050, 50.
Okay. Dunkin' Donuts regular black.
1040, 50.7.
50.7. Dunkin' Donuts decaf black.
1400, 36.4.
Okay. Dunkin' Donuts regular black.
1020, 51.1.
1020. And what was the temperature?
51.1.
Okay. Dunkin' Donuts regular milk.
1130, 48.2.
Okay. Starbucks regular milk.
1250, 48.
Okay, Starbucks regular black.
990, 51.
Okay, Starbucks regular milk.
1200, 49.
Okay, Dunkin' Donuts decaf black.
1380, 36.8.
Okay, Starbucks decaf black.
1560, 32.3.
And Starbucks decaf black.
1540, 32.7. And then the last one should be 1790 and 30.
And 30? Okay, so what was the example of what was written on the board? What's the name for that form that we filled out?
Data sheet, quick sheet.
Check sheet. Data or check sheet. Yep. And hopefully you got a sense of how much non-value added time is associated with using a check sheet by writing it down on a sheet of paper and then having to enter it into a computer.
Build on accuracy.
Yeah, exactly. As you can see, I fat-fingered a couple of them. I had to have her repeat it, and we have all these possibilities for transcription problems and everything that goes along with it. But check sheet and sort of what the exam is on. So be familiar with data being collected on a check sheet. So where are we? Design of experiments, factorial. Normalized factorial design. Response, temperature.
Caffeination is the most.
Yeah, so we see that our biggest effect is due to caffeination. That's kind of interesting.
And it increases.
Yeah, we also see that there's an increase that's due to milk, the presence of milk. And the store has an effect, but it's much smaller than our milk effect and our contamination effect. Kind of interesting.
Three-factor interaction.
Yeah, we do actually. It does suggest that we have a pretty strong
Heard of.
Yeah, kind of interesting. Okay. Let me get my results. So we get a regression equation. Which of these are statistically significant? We see that store is statistically significant, caffeination is statistically significant, so is milk. That's kind of useful. We have an R squared of 95%, which is really good, right? Because what does R squared represent? 95% of our variation in our output, our total dissolved solids, is explained by our inputs. That's right. Okay. So that DOE. Yeah. Okay, so let me make that B. Okay, so here's a cube plot. So based upon this plot, oh, did I do that for temperature or TDS?
TDS.
But why is it? Looks like it's doing temperature.
That milk that store
Just out of curiosity.
caffeine decaf.
Not so different.
No, but look at the numbers. They're 49.5, which is looking like our temperature numbers. Did I mislabel them?
That's
Okay.
right.
No, hang on one second. Yeah, so that looks like the temperature numbers. Oh, here like temperature numbers. Yeah. Oops. Yeah.
TDS one.
Yeah. it's labeled them. See, another reason why. So it's, guys, didn't pick up on that. Like, rely on you guys to make sure I don't do something stupid like that. Okay. So now let's actually look at the TDS when we're actually thinking about the TDS. Okay. Now that we're actually going to TDS, fortunately, we get the same result. Okay. So now let's go to our Q plot. None of you guys picked up on that. Yeah. That looks better. Okay. So if we wanted to maximize the total dissolved solids, which we think is a very good proxy for the taste, what configuration of factors would we use?
Yeah, Starbucks.
Well,
Okay, so we want to get the highest possible value, right?
Right.
So our high, is there anything higher than 1800?
yeah.
Okay, so that corresponds to Starbucks with milk, because it's on the back, and decaf. Because decaf's the top of the box.
I misread, yeah.
That's why the first time you look at the cube plot, it's sort of a little head spinning, but it's a really useful tool because it allows you to show you the interaction of multiple effects and in a space that you can sort of understand what's going on. So is this kind of what we expected to see? Well, we expected the milk to, when we originally talked about it, you said that we expected milk to have an effect and to be a pretty big effect. And we sort of supposed that we're putting more non-water into our water. So we should see our TDS go up. And particularly because milk has a lot of calcium in it, we intuit that calcium is conductive. Well, calcium per se, it does ionize, and when it ionizes, it is conductive, yes. So we thought that milk was going to increase it. So that was pretty good.
Decaf jump.
Yeah, the decaf jump. We didn't foresee the decaf jump. And this happens every time.
Besides the fact that it just jumps without the milk.
Yeah, well, there's a difference in decaf, right?
Is
So,
it the finer
well,
grind?
they're ground to the same standard. So the same grinder grinds the decaf and the regular beans. They physically look the same just from looking at the beans. And this is a phenomenon that I have observed, and I have a couple different explanations for it. The first of which is the decaffeination process is actually chemically very nasty. Basically, the beans are washed with acid, and the acid leaches out the caffeine molecule and some other things. That's why it doesn't taste this good. So that's one of the explanations. The other explanation is that decaf is roasted longer because they're trying to infuse more flavor into the bean to compensate for the taste that's lost through the chemical leaching process. The other argument, which is a pretty compelling argument, is that through the chemical leaching process, it makes the coffee bean itself softer. So it's more easy to be ground. So it actually grinds up more and dissolves more, just because it's changed the molecular structure and the structure itself of the bean. So when it gets ground up, it grinds up a little bit. But I've observed it, it's there, I can't explain it. I have some hypotheses, but it's kind of cool. Because that's one of the neat things when you do an experiment like this. You don't know what the results are. You have an intuition, and then you collect the data, and sometimes your intuition is completely wrong. We all kind of suppose that there would be less total dissolved solids in the Dunkin' Donuts coffee, in the decaf coffee. And this pretty much well shows that, yeah, there is. There's actually higher total dissolved solids as a result of decaffeination. So our intuition was right on milk. Our intuition was wrong on caffeination. What about the Dunkin' versus Starbucks thing?
They're about the same.
Yeah, they're really about the same. Kind of interesting. Not exactly what our intuition was. Was this helpful about understanding what design of experiments is about?
Yeah.
It's one of the hardest things to teach in this body of knowledge, and I haven't come up with a better way of doing it. So I think now that when you're on the exam, when you're thinking about factors, you'll think about Starbucks, Dunkin' Donuts, those being stores. Those are factors. Caffeination, decaffeination. Those are the levels that we set our factors to. So factors are the things you're going to change. Levels are the things you change them to. And the way you interpret a Q plot is just like that. And the purpose of using design of experiments is to try to isolate the resulting effect from different factors. If you've gotten that, you're where you need to be for design of experiments. I've been more or less good. Please take some more coffee. Coffee makes everything better.
Can you, depends how you set up, can you do the contour plot?
I can, but we'll see if we have some time at the end, and maybe I'll loop around and do that. Okay, so now we're going into the financial metrics. And in my personal humble opinion, for my 2 cents for what it's worth, which is less than 2 cents, I think the body of knowledge should be more biased towards this type of material. It's likely you'll see 1 or 2 questions on the financial aspects of Six Sigma. I think that's a mistake. I think one of the big important things of Six Sigma, it's there from your project charter on through, is making the business case and making sure that what you're doing makes dollars and cents sense. So if this were me, there would be more on calculating the internal rate of return and return on investment and doing things like the discounted cash flows to recognize the fact that $1 today is very different than $1 10 years from now. Because a lot of times your payback for particular capital intensive projects, you're not going to make back your money in the first day it's running. You're going to be looking over a longer time horizon. But in looking over that longer time horizon, you are foregoing other opportunities for that money to be doing other stuff. Or you're paying out debt services, interest on those loans. But it's not a huge aspect of the current body of knowledge. I was hoping when they redid it, this would be a bigger focus area. They unfortunately decided not to heed my advice. So there's some keywords. You're probably pretty familiar with these because you use them every day in business parlance. So this return on investment, ROI. So it's a measure used to evaluate how effective your investment was. Then there's the net present value. So it looks at and compares the present value of money today to some value of money in the future, taking into account inflation and returns into account. So what was your foregone opportunity cost for making this investment? Well, you could have invested it in treasury bills that are yielding less than 1%, so there's not much opportunity cost associated with that, but you've foregone the opportunity to invest in some other project. So net present value is looking at the effect of today's dollars versus tomorrow's dollars, or many years into the future's dollars. So internal rate of return is the rate of return used in a capital budgeting to measure and compare the profitability of investments. And then there's the cost of quality, which is the non-accounting technique for classifying the cost associated with non-conformance. So ROI. So it's the return of an investment divided by the cost of the investment. And it's generally expressed as a percentage. So it's the gains from the investment minus the cost of the investment divided by the cost of the investment. So put it into stocks. It's the price you sold it for, the cost you bought the original stock at, divided by the cost you originally bought it at. Then we have the net present value. That's the difference between the present value of cash inflows at the present day value and outflows. It's used in everything. How many of you have done net present value calculations? Yeah, it's pretty much a staple to any capital project, where you have to justify the fact that you're investing today and over the long term you will be able to pay back. Obviously, it's sensitive on what the returns will be into the future. It's sensitive on what future interest rates will be. And the calculations are a pain to do by hand. Fortunately, there's always tables and you just go look it up in the tables.
What's the little t?
Time. How many time periods?
Like 12 months?
Well, it depends. If you're on a monthly, it would be 12. If you're on a yearly, 1 would be a year. It depends if you're compounded continuously, monthly, quarterly. It relates to how many compounding periods you have. If you take the PE exam, you slog through having to do these for really weird time periods because they don't want you to use the tables. They actually want you to do the calculus. Well, yeah, summations.
Wow.
It's more just an exercise in. It's like you're doing the ANOVA table. It's not hard, but you're doing so many repetitive calculations essentially by hand that you will eventually move it up. Okay, so then we have the internal rate of return, which is the discount rate often used in capital budgeting projects that makes the net present value of all cash flows from a particular project equal to 0. So it's what rate of return do you need to have to basically pay for what you're doing. So you generally use the internal rate of return to rank projects. So a higher internal rate of return is a better project to fund. Okay, so you should be familiar just with what those terms are. They won't ask you to calculate them on the exam. Just know those are the financial metrics that your projects are being evaluated on. So you use them at the end when you're closing out the project to say, hey, did this work? And you use it on the front end when you're building your business case on your project chart.
Do they abbreviate that? Is that like IRR?
Yeah.
Or something?
Yeah, internal rate of return. It was abbreviated when I introduced it. Right there. So now getting back into more of the quality stuff, leaving like to the business stuff, cost of poor quality. This is actually something that I think is really important, and it sort of motivates your thinking. This is not an accounting concept. This is more of a engineering quality continuous improvement project. And it recognizes the fact that if you can prevent a defect from happening in the first place, it's the cheapest possible way for you to interact with that defect. If your customer finds it, it's really expensive. It generally involves lawyers and warranty claims, and everything is bad. And as you go from there being very little cost to not having the screw up happen in the first place, to the lawyers getting involved, it grows a lot, and it grows exponentially. So what it does, what the cost of poor quality does, is it tries to divide up the costs associated with doing something wrong, with screwing up, into 4 buckets. The first of which is your prevention cost. So that's everything that you do related to your design to stop a screw up from happening. So it's all of your poka-yokes. It's all your design for manufacturability. It's everything that you do to make sure that your design is robust enough that when a problem doesn't happen, that there isn't a defect generated. Then there's appraisal cost. So appraisal cost is the cost associated with your quality functions that are trying to detect if a defect has happened. So that's all of your traditional quality functions. So anything related to the gauging associated with measuring and inspecting the part, that's appraisal cost. The inspector salary, who's actually looking at the part, that's appraisal cost. Any sort of internal audits that you do, that's appraisal cost. Starbucks has an entire team called Plaza that goes to the various stores and will make sure that their products are marked correctly, that they have the proper expiration date, that the proper procedures are being done. Those are all appraisal costs. So any internal or external audits you do are appraisal costs. Then we have internal failure costs. So internal failure costs are the result of a defect being detected before it leaves your facility. So that's the scrap, if the product is scrapped. It's the rework cost. And that's internal failure cost. So that's the cost of a failure before it's been delivered to your customer. Then there's external failure cost. So external failure cost is the cost associated with a non-conformance, a defect, a screw-up, when it's discovered by your customer. So that could be you lost the customer. That could be a warranty cost. That could be a product liability cost. That could be your customer service department that has to deal with the irate customer calling in. Those all relate to your external failure costs. So story time. At American Standard, like most large manufacturers, sells the same product under different brands for different prices. If you've ever worked in a manufacturer, you're aware that that happens rather frequently. L'Oreal is the most egregious. They sell the same green goop for hair under many different brands, made on the same assembly line, and they get different labels and sold everywhere from $5 a bottle to lots of dollars a bottle. And they hide the fact that it's L'Oreal. The fructose line is fructose, or whatever the green one is really egregious. That's L'Oreal, and you can't find it anywhere on the market. But at American Standard, like what?
Garnier?
Yeah, no, not Garnier. It's it starts with an F. It's the
Fructis or something.
yeah, like Fructis or something like that.
Oh.
Next time you go down the shampoo aisle in the supermarket, it's the green one. It's actually made by L'Oreal and Cranberry and where are they? I know
Piscataway?
they're all over. They're over there. So at American Standard, we sold the same toilet under different brands. Functionally the same components. The only difference was that the American Standard version had American Standard sticker on it that was burned into the product, was glazed in. So it was this 10-cent sticker that was fired into our product, and then once it was stuck to it, you couldn't unstick it. But it was functionally identical, had the same components, held to the same specifications as the Elger version, as the Crane version, or as the Porsche version. Same thing, same piece of ceramic made, same mold, same everything. Only difference was a 10-cent sticker. But the nature of the manufacturing process at American Standard was such that they would all be manufactured at the same time, and they would all end up mixed up. So at the end, so they would go through the manufacturing process. There wouldn't be any real difference, except one would say American Standard physically on the part, and one would say Elger. So it would come to the final packaging line, and the packaging line would be getting whatever happened to come out of the kiln. So they would look at it and say, oh, this is American Standard, and put it in the American Standard box. As you can imagine, occasionally, yes. So it's a 10-cent sticker. So our initial problem was 10 cents. So if the guy in the final packaging line realizes it, it's an American Standard, and he puts it in the American Standard box, there's no cost. If he puts it in the American Standard in the Elger box, that's a problem. But if he realizes it right away, and he's just like, oh crap, before he seals the box, no big deal. He lost some time, we lost our tack time, but no big deal. We didn't lose any money besides his time. But what would happen a lot is he would put it in the Elger box, he would seal the box, and then it would go to the loading dock where it would hang out for a day before the trucks came to pick it up. And we would periodically do dock audits to make sure that the stuff in the box was what it was supposed to be in the box. So if we found the American Standard hiding in the Elger box and the Elger hiding in the American Standard box, we would be out the cost of the box. And the boxes were about 25 bucks a piece.
Wow.
Yeah, cardboard's very expensive. Particularly cardboard that's going to transport a relatively fragile thing is even more expensive. So we're out 25 bucks because of that 10-cent mistake when we found it on our dock. So that's still an internal failure cost. So we then shipped the thing from our factories in Mexico to our distribution center in Ohio. And we would periodically do audits of our stuff on the shelf in Ohio. And we would still find the American Standard hiding in the Elger box. At that point, it cost us about 50 bucks because we had the cost of the box. We had the additional labor cost of having to repackage this thing in the US. We had to have the inventory of boxes to let them repackage the thing in the US. So we're now out 50 bucks. So our 10-cent mistake is now up to 50 bucks. Okay, so Elger and American Standard sell through different distribution channels. So Home Depot has an exclusive with one brand, Menards has an exclusive with another brand. They kind of tried to hide the ball that they're the same exact product, made to the same standards, with the same components. So occasionally we would get a phone call from Home Depot, Lowe's, or Menards saying, you guys screwed up. We just opened one of your boxes, and it's supposed to be American Standard, and it says Elger. You can imagine what that does to our customer relationship. And what would we have to do? We'd have to give them a complete refund and say, we're sorry, we're sorry, we're sorry, it'll never happen again. So now we're out the $100, what we were selling them to Home Depot, Lowe's, and Menards for. So now we're at $100. So that 10% mistake is now up to $100. We're not completely done yet. So once every quarter this would happen, is we would get a phone call from a homeowner, irate that they have a all American Standard fixtures, they've been a loyal American Standard customer forever. And they just redid their bathroom, and now they've got this Elger toilet in the middle of it, and they're disgusted. Even our customer care department would be like, look, we'll give you a credit. Well, it's the same functional thing. There's no difference. No, I wanted American Standard. So what would we end up having to do? Give the customer a complete refund, pay a plumber to go out and remove the perfectly good Elger, and replace it with another brandy new American Standard, and then pay to dispose of the Elger, even though it was probably never used. So our 10-cent mistake at the end of the day was about $3,000. And at no point did this actually affect the functionality of the product. So our 10-cent screw up turned into a $3,000 screw up.
Wasn't that even bigger because if you found one during your audits? Did you open up
Wow.
everything?
No, because we knew that it was going to happen. We just knew that it was randomly coming out of our kiln that we had a mix of American Standard and Elger, and we relied on the operator to be right. The operator being right or wrong is independent of him being right or wrong the next time. It wasn't something systematic. I made the case for and was not able to get the financial wherewithal to fix the process such that this couldn't happen. And they weren't willing to make the investment. They might have now, but that was one of the projects that I begged and pleaded for funding for, and they wouldn't give me funding.
It was like you need a barcode.
Yeah.
You know, like we have very similar, like we had servers, right?
Yep.
Coming off our server line. I work in data
Yep.
storage. So we load an image on one.
Yep.
So the servers are exactly the same except
Yep.
for software. We did very similar. Customer opens the box. Where's my image? You know, this is
Yep.
just a basic server. We're charging like a couple $1,000
Yep.
premium.
Yep.
Same issue. You got to send somebody out there.
Yeah, and it's really awful, and you look like an idiot.
Yeah. Yeah.
The solution, I was trying for a multifaceted solution because the biggest problem we had, since they were functionally identical, is the demand for each one of the products would move up and down, and you have two random things moving around. So invariably, we'd have extra Elger sitting on the shelf and not enough American Standards. So as I was working through the actual process, which took about 2 weeks, it was a matter of how do we mark these products at the end such that they're generic until they physically get put in a box. And there's a way of laser marking them such that you get a really nice mark and they can be generic the entire way through. The part that was actually really cool about that is it allowed us to sell unbranded products. So every manufacturing process, you have stuff that doesn't make your A quality. And depending on what industry you're in, there's different ways to sell off your B stock. But we didn't want to dilute our brands by having the crappier version already marked with our name. But if we held our inferior version that was fully functional but had like a scratch or just had an imperfection in it, if we could sell those under a different mark or just unmarked through the wholesale trade, it's like, it's free money. And I couldn't get them to go for it. But American Standard is now owned by a Japanese company, so maybe they got their act together. Hi, videotape.
You ever been to the plant that used to be down in Trenton? Hamilton?
I joined the company about 3 years after the plants in Hamilton closed. I knew many of the engineers from there. They're still there. And they actually did a really nice job making that into condos.
I was in a dump in a swamp
It's a beautiful,
next to the railroad track.
they did a beautiful rehab there. It's a beautiful condos. They actually kept the kiln, and that's one of the main hallways in the condo unit. It's extremely well done. And also they did a nice rehab of that train station. So it's actually kind of a nice area now. And you have the grounds of sculpture right there. So you have the random sculptures kind of lurking about.
We used to play in the salvage dump there and put pennies on his railroad tracks until they had the Amtrak trains. Blew them into smithereens and never found them.
Remember, you're on tape.
That plant was about 3 miles long too.
Yeah,
You got one heck of
huge.
a workout.
Yeah, our ones in Mexico were over 1 million square feet. The strange part about toilets is, as a normal human being, you've maybe seen like 10 at one time. And to be in a warehouse where you, as far as your eye can see, are all toilets stacked to the ceiling, it's sort of surreal. It's definitely, I guess that's some
Supply and
stories.
demand.
Make a neat photograph.
The other, I have some cool ones, but the other thing is that the life expectancy of a toilet is about 20 years. So the question is, where the hell do they all go? Because prior to the Clean Water Act, the technology didn't really change on the 5 gallons per flush. Post the Clean Water Act and requiring 1.6 or 1.2 gallons per flush, really strange specifications because the tolerance zones actually overlap. The tolerance zone on a 1.6 gallon is plus or minus 0.4 gallons. Such that a 1.6 that's actually flushing 1.6 can be legally sold as a 1.2 because it's 1.2 plus 0.4. And I argued, since that was the legal standard, we should only produce 1.4. Why bother with having 2 sets of components for everything? We can legally sell it as 1.2 and 1.6, split the difference and sell that. Yeah, I nearly lost my head on that. That's actually one of the things that. Okay, so
Makes perfect sense.
yes, but the marketing people didn't want to have on record that we were deliberately going to lie to our customers. Okay, so now let's put these into the proper bucket. So registering for the course. as it relates to the process of becoming Greenbelt certified. Is that a internal failure cost, external failure cost, prevention cost, or appraisal cost? Prevention, very good. Failing the practice test.
Appraisal.
Appraisal or internal failure cost, you can say it both ways. Failing the real exam. External. Purchasing additional test questions.
Prevention.
Prevention or appraisal. Going to class.
Prevention.
It's probably prevention. Buying the calculator.
Prevention.
Prevention, right? You're buying something to stop you from
Or
making a leak.
appraisal, it's sort of a-
Well, appraisal relates to the actual detection of if you screwed up. Prevention is stuff that you're doing to stop you from screwing up in the first place. So as you saw, if you have the calculator, it makes doing the calculations easier. Therefore, you'll make fewer mistakes. So that's really prevention. Taking time off to work to study.
Prevention.
Prevention.
Yeah.
What did you say inspector salaries were?
Inspector salaries are appraisal.
Appraisal.
Yeah, because that's everything associated with the process of making sure that if a mistake happens, you're able to detect it.
Same as buying an instrument. You're
Yep, buying an
a
instrument, yep. Yep. It's different if you're buying a machine that actually makes the device. So if you're buying a better machine that has a lower defect rate, that's going to be in prevention because you're stopping the defect from happening in the first place. So appraisal is all your machinery and all your inspection equipment that enables you to detect if something goes wrong. On the external failure cost, always be able to be conscious of the environmental component. So if your plant does something bad and leaks out nasty chemicals, external failure cost. So your EH&S stuff tends to be the external failure cost. So if you hurt an operator, that tends to be an external failure cost. Okay, now I'm going into something I kind of like. This is the Kano model. We touched upon it a little bit earlier on when we were talking about motivations. It was developed by Kano in the 80s, and it basically tries to identify your customer needs and partitions them into 3 different buckets. The first of which is the basic, the hygiene factors. These are the things you expect to be there, and you're only going to be bothered if they're not there. So if you check into a hotel, you expect there to be a bed. Have any of you checked into hotels without a bed? I have.
How is that possible?
They had configured the room for a meeting,
Oh,
and they just didn't take it out of the normal room stock. When you check into a hotel, you expect there to be no one else there, right?
well, possibly.
Well, one time the hotel gets a pass. The company had 5 rooms, and they just gave it to one of my coworkers. So I can understand that one. In the other 3 cases, it was just random stranger.
They look at your fishbone diagram.
That's strange.
Yeah, it happened 3 times at 3 different hotels.
Wow.
You expect there not to be lace women's underwear next to your bed. Don't incriminate yourself. That also happened to me at a hotel.
As long as she was there.
She was not there, but
Well,
that was sort of a trip. That was a weird trip to Tampa.
Cinnamon Motel and you just happen to.
It wasn't even at a. It was at a brand name
Wow.
Marriott. It wasn't a Marriott, but a Marriott level hotel.
Yeah.
It wasn't.
So it was a 4 or 5 star.
It wasn't 3, 4 star. It wasn't. It was the standard brand name hotels that you see everywhere. It wasn't a motel, whatever. What else? What else do you expect there to be there? The basic factors when you check into a hotel. The things that you're not going to give credit, but you're going to be really pissed if it's not there.
Elevator works.
Bathroom, towel.
Yeah, bathroom only if you're in the U.S., right? So if you're in other places in the world, there's 1 bathroom per floor, and that's the standard. Yeah, so if you rent a car, that's one of the neat things. If you rent a car in the U.S., you expect it to be automatic, right? If you rent a car anywhere else, it's going to be a standard. What?
That's fine with me,
Yeah.
except for shifting with the left hand.
The thing that always bothers me about renting cars like that is if you don't drive a standard that often, and the parking lots for rental cars are always so goddamn tight. So it's like, wait, I don't quite have a feel for this clutch. And I'm in this really tight parking lot. I'm in a strange country. I really haven't slept. And you expect me to back this freaking thing out of here without hitting anything? Has anyone else had that experience? Don't. I didn't hit anything, but it's like, guys, couldn't you just think this is a little bigger to recognize the fact that like every clutch is just a little bit different?
Or how many times did you stall out before you finally got it in space?
Yeah, and then they generally have you like go these like serpentine things that are really tight. Okay, so the basic factors. These are the things that you do not give your vendor credit for it, but you expect them to be there. If they don't provide them, you're really pissed. So these are the hygiene factors, the things that you're assumed to be given. Wi-Fi is a great example that we're going to walk through, is that I think free Wi-Fi at a hotel is a hygiene factor. I think it should be there, and I'm really pissed if it's not. Performance. These are the things that your customer is using to make the decision to use your product or use your competitors. So the better job you do, the more your customer is going to reward you. So the x-axis here represents how you're executing. So if you're moving to the left, you're doing worse. If you're moving to the right, you're doing better. And the y-axis represents your customer satisfaction. So moving up, more happy customer. Moving down, unhappy customer. So then we have the excitement factors. The Steve Jobs, but wait, there's more. So these are when you've gone above and beyond, and you've really excited your customer. It's something that you've differentiated your product on. If you check into DoubleTrees, they give you free hot cookies. There was one DoubleTree in DC that I frequented so much that if I happened to not be staying at that DoubleTree, if I was staying at the hotel down the street, I would actually go up and get free cookies even if I wasn't staying there. I was staying there every weekend, and I was going through Priceline, so occasionally they put me at the DoubleTree, occasionally they put me across the street, and I knew the check-in person. I was like, yeah, have a cookie. Like, are you staying with us? No. I still have a cookie? Here. So the excitement factors, these are the wow factors. So if you execute these well, you'll be rewarded. If you don't have them, you're going above and beyond. Your customer doesn't expect them to be there. So that's the little mint on your pillow. So to put it together, we have the excitement factors. Those are the things that are going above and beyond that your customer is going to reward you for if it matters to them. And if you don't do them, you're not going to get penalized for it. You have the performance indicators. Those are the things that your customer is actually using to decide where to stay. And then you have the hygiene factors that you don't get credit for. So as it relates to hotels, check-in time is one of my performance indicators. I don't get why it takes so goddamn long in certain hotels. There was one hotel, the NH in Mexico City, where the check-in time took 30 minutes. It was the hotel directly adjacent to the airport, so you didn't have to get a cab or anything, you just walk there. And it took 30 minutes to check in every flipping time. I actually got so frustrated, I would take a cab to a hotel half an hour away just so I didn't have to go through the check-in process. So you can think about the different performance indicators are over time. There's a 10 to what used to be an excitement factor becomes a performance factor, becomes a hygiene factor. A great example of that is Wi-Fi. So when Wi-Fi first started showing up in hotels, it was like, cool, that's really cool. I didn't have to plug in. And then it got to the point of, okay, well, I really want there to be Wi-Fi. And I'm going to stay at the hotel that gives me free Wi-Fi and doesn't have the audacity to charge me 20 bucks. Now it is, if you're not giving me free Wi-Fi, I'm pissed and I'm not coming back. Or you can look at the progression of safety features in cars. So you can remember things like anti-lock brakes. Anti-lock brakes went from being a very high-end feature that was a delighter on the luxury cars. It then became a selling point that this car, our model has anti-lock brakes where our competitor doesn't. Now, I don't think you can buy a car without anti-lock brakes. You can look at passenger airbags or rear view cameras, where now they're required by law for no apparent reason, even though there's no data to support that they do anything. But it makes it like driving a car like a video game, which is kind of neat. But you can see there's a general progression from things that used to be over the top, the wow factors, get accepted to be the performance indicators, the things that your customers are actually going to care about, and then it becomes the, hey, why the hell wasn't this here? Okay, so now let's apply it to this taking this course. So what are the basic criteria for the course that you're taking? The things that you're not going to give me credit for when you do your evals a week from now.
There's heat, light.
Yeah, the facilities, right? What else? The things that you expect there to be there. You expect me to know something about what I'm talking about, right?
Yeah, course material.
Yeah, you also expect me to speak English clearly, right? Some of you that have gone through engineering programs have realized that that can be an issue. Or you can think about colleagues where they've given presentations and language has been an issue. One of the most humorous experiences of my life was acting as an English to English translator. At American Standard, our ops folks were in Mexico. We were using software developers in India. And the guys in Mexico spoke English. The guys in India spoke English. The English to English would not work, but they both can understand an American accent. So I was translating English to English, then back to English to facilitate communication between people speaking English in Mexico and people speaking English in India.
Was part of it slang as well?
No, it was just
Or just King's English versus.
it was just diction. And the pronunciation of vowels was really what I was able to drill in on, is that they were both imprecise in different ways, and they didn't cross over. So what are the basic criteria? Things that you thought you were getting that you would have been really pissed if I didn't do.
Slides.
Okay.
Well, your course outline would be.
Well, the course outline,
The initial, what the course is going to cover.
okay, but that's more the performance characteristics, right? That's what what motivated you to take the course, right? It was the course outline. A couple of you emailed me or Richard to get a sense of what was going to be covered in the course, things like that. Those are more the performance side. But the things that we didn't even have to say, right? So you're going to be in a room. It's going to be relatively quiet. There's going to be seats. There's going to be tables. And I'm going to stand up here. I'm sort of going to know what I'm talking about. I'm going to be prepared for class. At least I think I'm prepared for class. That's one of the things you'll be evaluating me on in the week. And that I'll speak clearly and I'll present the material in a way that sort of makes sense. That's sort of the hygiene factors, stuff that you're not going to give me credit for. So the performance characteristics were the outline, right? The material that we were going to cover. The fact that we were going to, it was a 8-week course for 5 hours. We're going to spend about 40 hours in the classroom working on this stuff. So that's the stuff that you probably looked at when making the decision to take this course, right? Okay. Yeah. What were the delighters? The things that was like, ooh, that's kind of nice.
Coffee and the subs.
The coffee and the subs, okay.
The hands-on.
Yeah, the activities, right? That kind of delighter, using that as a performance indicator. The delighters were some of the war stories. Some people like them, some people don't. The other delighters could be the practice exams. A lot of the refresher courses don't have such an intensive forcing you to take the practice exams. I think it's really important.
The Scantron.
Yeah, like physically floating in the bubbles, like that it's an issue. It shouldn't be an issue, but it is. So you can see how those are the delighters. Those are the things that are really above and beyond that you didn't even know you wanted, but now that you had them, it's like, yeah, that was helpful. So we can see how the Kano model can be applied to something you've experienced, listening to me babble now for 7 weeks. Okay, now we kind of got a mishmash of improvement stuff. Have you ever seen this written out, SMART goals?
Yeah.
Yeah. So a goal should be simple, measurable, actionable, related to the customer requirements, and timely. It's in the body of knowledge, identified as something you need to know, even though it's pretty straightforward. Okay, so let's go loop back through Lean a little bit. So if we remember in the very beginning, when we were introducing what we're going to cover in this course, we talked about Six Sigma, we talked about Lean, we talked about how Lean is an emphasis on reduction of waste. And there's a cartoon that says it pretty well. So it tries to get 0 breakdowns, 0 delays, 0 defects. I like 0 Hoover. 0 accidents and 0 inventory. And what it really tries to do is eliminate or minimize the 7 forms of waste, the 7 forms of muda, which apparently in Croatian means balls. So there's overproduction. So that's when you produce more than your customer demands. That relates to wasted money, wasted opportunity, and you have to store the stuff. Then there's transport, excessive movement. So you're moving the stuff around. That's time, money, space. So you have inappropriate processing. Well, are you making this thing more complicated than it needs to be? Then you have unnecessary inventory, right? Do you have extra parts just sitting around? Every person that's ever worked in R&D has problems with unnecessary inventory, where we have the project we worked on 6 months ago that was really cool, and we throw it in the box, in the back of the cabinet, because we know someday from now we're going to go back to it. And we can tell you a war story of how we were able to dig through and find that one little bit of component that was hiding in a drawer somewhere. The maintenance departments are also great on unnecessary inventory. It's like, I can't throw that out. I needed something like that once. I am really big on that. Personally, I'm having lots of unnecessary inventory. Unnecessary motion relates to poor ergonomics or your work cell design. And then there's defects. So if you screw up, that's a problem. So do it right the first time. So there's the 5 S's. You should just be familiar with these being the housekeeping stuff. So now we get into other aspects of it. So some vocab. So MRP or ERP, where MRP is materials requirements planning, also might be materials resource planning, or ERP being enterprise resource planning. So what it's trying to do is it's trying to relate the production schedule to the end product. So matching demand to production. Then there's just-in-time inventory. So just-in-time is one of the ideas in Lean, where you're only producing when something is demanded by your customer. So the MRP version is generally referred to as a push system, and the just-in-time system is generally referred to as a pull system. So in the push system, it's all about forecasting your demand. So if you have a very good understanding of what your customer demand is going to be, as it's affected by seasonality and other factors, you can be very successful with a push system. In the case of your demand being rather erratic, you can get, it's the example of a pull system. So the comparison. So in the MRP environment, in the push system, it uses the forecast. So if you have a very strong forecast, you can optimize and level out based upon what that forecast is. If you're producing men's undershirts, you're probably pretty good to use a push system. If demand for men's undershirts tends to be rather constant. But if you're a toy manufacturer, it's pretty hard to forecast your demand. Particularly if you have someone like Oprah that announces this is the toy of the year, and then your demand went from nothing to a lot, almost overnight. Also, in just-in-time land, you have no inventory because you're only producing when it's demanded for your customer. So for the poll, we have limited final inventory, but everything is make or break. There's no installation. If something goes wrong, you're not delivering to your customer. So you can't hide anything in a poll system. If something breaks, it's directly going to affect your consumer. There's no buffer. In the MRP push system, you have that buffer. You can lead to large inventories if your forecast is bad. If there's a mistake, you're not going to discover it in a single unit. You might have implicated an entire lot. Okay, so in just-in-time land, we have some terms. So we have Kanbans. We met Kanbans before. So Kanbans are any sort of signaling system that allows you to know when to produce, so to trigger the production of a unit. We also see a restatement here of the idea of SMED, single minute exchange of dies. So that allows you to be able to change over one production line to the next very quickly. Also, in the just-in-time lean environment, there's an emphasis on individual responsibility and worker responsibility, because each and every product is being delivered for a particular customer. If that operator makes a mistake, if there's a defect detected, that's going to directly impact the customer since there is no buffer. And again, in just-in-time lean land, we're trying to eliminate all forms of waste. So that's by reducing inventories. That's by improving quality. If you don't make a defect in the first place, you don't have to rework it. If you're only making what's ordered, you're not wasting the labor associated with making the part, and then you're not storing it and having the inventory cost and dealing with the spoilage rates and the square footage associated with maintaining that inventory. You're wasting less time with people standing around twiddling their thumbs waiting for a changeover. You're only using the employees that are actually needed for your production, and you've eliminated clutter, which apparently is a good thing. So the idea here is that when you go just in time, you reveal a lot of problems because you don't have that inventory to act as that buffer. If something goes wrong, it's really bad because you've stopped production. But it also allows you to actually fix it. It allows you to focus where you're bleeding so you can stop the bleeding. So that's sort of a key concept, is that idea here that you want to decrease your inventory so you can reveal those problems so you can fix them. Otherwise, if you carry inventory buffers, a lot of times they're hidden. So just to summarize, so the advantages of the just-in-time is, as we kind of addressed, it's the single-piece flow allows you not to keep inventories. It allows you to respond more quickly to problems, but it doesn't forecast the demand. So if there's a big jump in your demand, you're not going to know it's coming, and you're going to be running around with your hair on fire, because every job is running around with your hair on fire. Okay, so just you should be familiar with the difference between the push and the pull system. And there is no absolute. There's no way to say that a pull system is better. There's no way to say that a push system is better. In certain circumstances, one works better. In certain circumstances, another works better. You can think about your relationship with toilet paper. You can think about your relationship with toilet paper.
You never know how much you're going to need.
Well, it's not that. Well, when you need toilet paper, you don't want to go to Markel up in North Jersey and request that they give you a sheet of toilet paper every time you need toilet paper.
Very good.
That would be a perfect pull system, right? You go to the manufacturer and say, I need toilet paper. Yeah, that's not going to work. Likewise, okay, let's say we're not going to go all the way to Markel, but you're going to go to the supermarket to buy the toilet paper when you need it. That's not going to work either. So that's an example where a push system works better, that you would hope that there's inventory sitting on the roll when you need it.
Speaking of lean, people use the term supermarket and buffer.
Yeah.
To mean something.
Supermarket is a small
Cache or something?
yes, small inventory of work in progress inventory where you have your supplies and associated goods, and it's arranged in such a manner that you can go up and down the aisles, kind of like you do in a supermarket, to get the parts that you need to assemble what you're going to do.
Compared to a buffer?
Yeah, a buffer is a stack of inventory that is of a particular component. What in the supermarket model, what you're doing is you're gathering the 12 things needed for your recipe off the shelf, and you're only gathering those 12 things. So it's kind of like if you're making cookies, you go to the supermarket, you get flour, chocolate chips, eggs, and milk. And you only get the amount from the supermarket that you need for making your cookies.
Okay.
In the buffer model, you would have to go to the milk buffer, the milk inventory, go to the dairy farm, get your milk, then go to the the flour mill to get the flour. In the supermarket, everything's together, but you're doing it in very small batch sizes. Okay, almost there. Control plan is the key to sustaining up gains from Six Sigma projects. So DMAIC, it's the C. The control plan is the final output of your project. So what it does is it ties everything together in a nice bow. It's the transitionary point from the continuous improvement team to the process owner, to the people that are going to be living in this world that the continuous improvement team came in and either built or modeled or completely tore apart. And it allows everyone associated with the project, particularly the champions and the stakeholders, to have confidence that whatever improvement was alleged is going to be sustained. So the control plan has lots of elements. So it includes how you're going to monitor the system on a going forward basis. So it's SPC. So all of the control charts we've been talking about to make sure that your process continues to operate as it was when the continuous improvement team was there. You can use automated process control, which is how if you put in instrumentation that automatically measures the characteristics of the product that are critical to your customer, your CTQs. They could be checklists, procedural checklists. They could be the pokey-okes that you put into your system such that the system is now improved so a particular defect cannot happen. It's updating your standard operating procedures. It's updating the training materials. It has the maintenance schedules. It has the reaction plans and responsibilities. So what happens if something goes wrong with this process? Who's going to go fix it? Here's just an example. So explaining what each are. Read this on your own. And again, we have CTQs on here. Which one of our characteristics are critical to quality? Which one of these things, these attributes of a product, matter to our customer? Specifying the control method. So how are we going to monitor these characteristics? Is it going to be a control chart? Is it going to be periodic inspections? Is it going to be audits? And then the reaction plan. So how are we going to respond if our control plan is violated? There's a blank one. Every company has a slightly different format for their control plans. It's not as standardized as it should be. Okay, so now into RACI charts. I dislike this material. So what a RACI chart is it's sort of a way of understanding who's responsible, accountable, and in control, consulted on various aspects of a project. So the person that's responsible is the doer, the person that's actually going to be involved with carrying out the improvement, carrying out the responsibility, the person that's going to be responsible for taking the measurements. That's the responsible person. The person that's accountable, that's generally the process owner or the person's manager, the person who's responsible if something goes wrong. Then you have the people that are consulted. Those are the people that are in the loop. So that's the stakeholders. It could be the champions. It could be the initial continuous improvement team. It's anyone that should be on the email chain, potentially. They have some input into a decision before it's actually made. And then you have the people that are informed. These are the people that should not be on the email chain. But we all find ourselves on these email chains when we're just the informed guy. Where this is just, yeah, you should tell them, but they have no authority, no decision, and we don't care what they say. Not that we don't care, but they're just not involved in the decision process. So what these have is on the extreme left is the actions to be taken. On the top is the functional roles or names of individuals. And you put an A if someone is accountable. You put an R if someone is responsible. You put a C if someone is consulted. And you put an I if someone's informed. So now create one of these damn things for your process of taking the exam, passing the exam. Yeah. So you need to identify who's responsible for you passing the exam.
Yeah, so you have to draw one. So you're gonna have, we're only gonna do it for one. So your activity is going to be passing the exam. So that's gonna be on the left where the activities are. Up top, you're gonna have the participants of you passing the exam. So it's gonna be you, right? Probably your employer, hopefully me.
Supervisor, boss.
Yeah. Whoever you're gonna tell. Your bartender, if you're gonna be crying into your beer. That's kind of like the running joke in law school. You end up at the bar anyway. If you end up at the bar if you won, or you end up at the bar if you lost. Are we drinking to celebrate, or are we drinking to our sorrows? I don't know. You make the reservations at the same bar too. Weird.
So basically, we would be A and R.
Okay, you're the doer, right? You're accountable. Yep.
And we're responsible for ourselves.
Yep. You're A and R. Okay.
Our bosses would be I, and maybe
They're informed.
C, pending.
Okay.
You know, they're helping to pay for it.
Yeah, that's probably true.
Consultant.
Yeah, they would have been consulted. What about me?
And the,
Sure.
the teacher.
Me. I'm probably just informed.
Accountable.
I'm not accountable.
You won't get more students if you failed in our attempt.
Yeah. Okay, maybe I'm accountable. Okay. Okay.
A little
Or
bit,
or you could,
Or you won't get paid. There it is.
what was the line of what we were saying, to pass the exam, or?
Yeah, pass the exam. I think I was just
They
more.
would be responsible too, in a way.
I don't perform any activity that's recent. Maybe I do.
Yeah, the teacher.
Yeah. Okay.
That page at the back. Brandon said this was the answer.
Oh, God. What's scary
We
is
have
they,
it on YouTube.
what's scary is they probably know what Brandon you're talking about. That's the scary part. Is that if there was a student that actually wrote on their comment card, Brandon said, I'm certain they knew which Brandon you were talking about. Just
So when there's that question that we write a comment about.
no, don't. As I've said all along with ASQ, just like forget that you know me. But sort of
Are you
infamous.
either gonna fail us or?
No, I'm just sort of infamous.
Look at that big magic marker out.
I'm just sort of infamous. If you guys haven't figured out, I sort of have an opinion, and I'm not afraid to open my mouth. Okay, so we gotta get the flavor there, right? So it's just a matter of someone's responsible; they're the one actually doing it. Someone's accountable; they get yelled at if it goes wrong. Consulted; they have some input, but they're ultimately not the person that's the doer or accountable for it. Those are generally your stakeholders. And then the people that are informed are the people that are tangentially related, that are affected by it, but don't have any influence in the ultimate decision.
Sure.
These can be used really well in certain circumstances. They tend to be consultant speak, and the consultants can bill for them. Yeah. They made a big emphasis on putting them into the body of knowledge for this present exam, so I thought we should have slides on them because ASQ decided to make them important.
I think you could use this for the team.
Yeah, you can use absolutely.
The minute taker,
Yep. Absolutely.
Black belt.
Yeah, they loop over onto each other. So ultimately, it will now be part of the team structure. They just snuck it in when they released the new body of knowledge, and I didn't update those slides.
So this would really be
It would be in the
part of
define.
the team rules.
Yeah, it would be in the
Use
team.
this chart.
Yeah, exactly. Okay, now into stuff I like. And now we are going to do our most colorful example, and I'm going to offend some of you, and I don't care. I like my example, and I don't care. So put it on your comment card that I give you an offensive example. I don't care. I like it. Don't care. It's staying. Yes, that's on video. Okay, so reliability. So we saw a bit of this. So for a system to work, we can have components in series. So for the entire system to work, so we have component C1 through Cn, everything needs to work. If one of them fails, the system fails. So as we saw when we were going over the midterm, that the probability of the system working is the probability of component 1 working times component 2 working times component 3 times component 4. So written out in cool math language, it's the reliability of each individual component I multiplied by each other. We didn't know, though, that means the product.
The monument means product?
It's kind of like the sigma. It's the multiplication version of the sigma. And if the components are the same, it's r to the n. Now we have components in parallel. So as we saw on the exam, if any one of these components works, our system works. And we saw the formula for that was 1 minus our reliability multiplied out minus 1. 1 minus that mess. Because this is like the probability of all the components failing. So the probability of all the components failing is 1 minus that, 1 minus that, 1 minus that, 1 minus that. Then we can see if they're all the same, we get this lovely formula. So then we can decompose more complicated systems by just applying the rules. So here we have C1 and C2 are in parallel or series. Series. And C1 and C2 are in parallel with C3. So we can replace C1 and C2, we can call that Q1. We can calculate the reliability of that combined component. So the probability that C1 and C2 works, let's call that Q1. And now we just have Q1 in parallel with R3. So we can just decompose them or put them together. Everyone cool with that process, that concept? I think this should be more emphasized on the exam. It's not. It's more in the certified reliability engineer body of knowledge, but I think it's really important. Because this is the type of things that you have that happen a lot. We need to make a part. It's got to go through 4 processing steps. Our yield from processing step 1 is 0.98. Our yield from processing step 2 is 0.96. Our yield from processing step 3 is 0.95. What percentage of our parts are actually ending up in the box? That's the stuff we do all day. So I think it should be a bigger emphasis on the exam, but it's not. But still the body of knowledge. Okay, process yield. The nomenclature here becomes kind of important. Process yield is defined as this, e to the minus dpu. So it's the natural base e. And dpu is the number of defects per unit. You can expect to see 1 or 2 questions on the exam that's calculate out the process yield based upon this dpu. So dpu is the number of defects divided by the number of units.
Can you show how to do the,
Yeah, the E.
yeah, the raise to the negative?
Yep. So you hit the E to the box, minus, and then whatever your DPU is. So 0.25 or whatever.
Where's the E? I didn't see a clear E key. It's hidden. Oh, it shares. Oh, the square is,
Yeah, this,
square is raised to that power.
Yep.
Okay.
yeah, I hit it twice and do it to the 10. But hit it once, it's to the E.
Where?
E to some power, 10 to some power.
Like that. And then you get the negative was what?
You hit negative.
Plus or minus.
Oh.
The number you're interested in.
Yep.
Thank you.
Yep, no problem. So we have rolled throughput yield. So rolled throughput yield is what I was just talking about, where you have a yield of processing step 1, yield of processing step 2, yield of processing step 3. Your rolled throughput yield is the yield associated with each one of those components multiplied by each other. That's rolled throughput yield. So yield is e to the minus dpu. Rolled throughput yields, those each individual yields multiplied by each other.
Same as in series.
Yep. That's why I think the concepts are really closely related. Because you can look at a component in an electrical system, you look at that as a component, and then you're in reliability lens, or you can look at it as a process with a certain success rate, and then you're in yield land. They're same thing. Okay, now time to annoy people.
Aha.
Time to offend people. Okay, the current estimated cost of raising a child is $250,000. On average, heterosexual couples have 2 sexual encounters per week. Based upon the CDC data on the next slide, what is the expected cost for having sex for a year using only condoms? Condoms with spermicide. Condoms with spermicide and the pill, assuming the failures are independent. What about a single tryst? And there we have our failure rates of the various forms of birth control. So everyone understand the call of the problem, what we're asking about?
18% failure rate. Wow, that could just well be an AIDS rate.
I'm not presenting this as being factual data. All I'm saying is it was taken from from the CDC. The citation is provided. And if Brandon were the ruler of the world, this is the way sex ed would be taught. Because we'll get to a calculation at the end, which means that you should go find something else to do on Friday night.
So do you group them in series or in parallel?
Well, different, he has multiple questions.
No, I'm just looking at it random here. If you combine 2, is it series or parallel?
Oh, well,
I think,
what do you think?
I don't know now. Now it's a different frame of reference. Resistors I can deal with.
Okay, but this is a more realistic type question.
It
right?
is. Yeah, direct impact to me. Not so much as a transistor radio.
It definitely gets people's attention and probably pisses some people off. So what do you think? Are these and that's one of the reasons I put this question up there, because are these in series or are they in parallel?
Have to be parallel because one can work while the other fails.
And then the system's still good.
Yeah.
And I actually did send this to a girl once, so this probably should be added to my fishbone diagram.
She said no tryst for you.
This wasn't a tryst possibility, therefore I would not have sent this to her. She was complaining about her romantic relationship and certain aspects of it, so I just sent her the calculations, and she laughed.
Do you know Pete Anderson? He used to be in the Princeton section.
The name rings a bell.
He worked at Carter Wallace with a statistician.
I think I know him from Carter Wallace, actually.
Yeah, he used to be a proctor. It was the hardest interview I ever had. They bought Young's drugs, and I guess they got nominated to some AIDS conference. So I go for an interview, and they made the male condom there.
Mhm.
Pete pulls out this glass thing and
Yep.
puts it on his desk. I'm sitting there in a suit trying
Yep.
to be serious. And it's staring at you in the face.
Yep, I did work in their packaging lab for their condom packaging, and
You saw the test device or whatever. It was.
we actually developed. My predecessor at Johnson Scale developed much of the test requirements and actually on the amount of the popping force of condoms.
Wow.
But you would go into have one gentle lady who was the researcher on that. You walk into her office and on her desk would be all sorts of interesting things.
I guess you get bored to it or immune to it, but when you say it the first time or an interview,
I had something stranger. I interviewed for a patent law job, and the company, the one attorney whose job was getting patents for condoms. And we had a really funny discussion about, are they design patents or are they utility patents? So the distinction is a design patent covers the ornamental design of something with utility. But if it has utility, it has some sort of function, it's not covered by a design patent.
Huh.
So using very little creativity, you can see how you can get to a very funny conversation very quickly on trying to tease out the difference between what's ornamental design in a condom and what is utility in a condom. But I can definitely relate to job interviews having weird conversations like that that are completely above board. Okay, so how are we doing on this? Have we agreed that our birth control methodologies are in parallel, right? Theoretically, if the condom breaks, well, then the spermicide will work. And if the condom breaks, the spermicide doesn't work, hopefully the birth control pill works, right? So there are 3 components to the last one in parallel. Okay, so how do we draw the block diagram of our system?
Well, I think you looked at the cost of the stuff.
Oh, fiddlesticks. It's offset. I didn't also factor in the cost of STDs and STIs, so they offset. Okay, so we have 3 components in series, right? In parallel. Sorry. Is there another way of thinking about this that would actually get us to be in series? Or do you just want to agree that they're all?
Well,
Okay.
Taking a
you have
pill,
a
an oral.
3-point question for the first question. And then the second question is the twist, but you don't even say.
We didn't get there yet. We did.
Oh,
We did. We said that they have 2 sexual encounters per week, and the data is given you per.
Okay, so it's 104 a year.
Yeah, we'll get there. So what's the reliability of component 1?
Condom.
Yeah.
I'm only 18.
No, reliability.
Oh, he's 82.
Yeah,
Yeah,
82.
the reverse.
Okay. Methodology 2. Spermicide.
72.
Okay. So we have 3 components in parallel. What do we do? So we do 1 minus 0.82 times 1 minus 0.72 times 1 minus 0.91 and 1 minus that whole thing. What does that give us? What do you got? What do you got?
There we go, sorry.
That's okay.
Mistake.
9955. 996.
Let's go up one more decimal point. What's the next decimal?
5.
Do we agree?
Yep.
Okay. So that's the reliability of our system. So what's our expected cost of problems? What's our expected failure cost?
250K.
Well, that's what happens if we have a failure.
Right.
So how frequently are we going to have a failure? Well, it's going to work 99 point.
Right, 1 minus that.
1 minus that, which is 0.45.
It's 0.5% failure every event.
Okay, so what's our expected cost of a failure? Expected failure cost for the year? How much does it cost us to have sex for the year?
What do you do with it? Multiply it? Huh?
Yeah.
4 or 5% failure?
Times $250,000.
Right.
Based upon your face, I think you saw the number.
Yeah.
What's the number?
113,400?
No, that's too much.
Oh, I made it percent, so move the decimal.
So
11,250.
okay, so based upon that, what's the expected cost of one particular tryst if you're having 104 trysts per year?
$104,000?
Well, two per.
Well, you can, you're either pregnant or you're not, so it's gonna be the 250.
Each time.
Well, you're going to divide this by 104, right? So what do you get? 1,100 divided by 104.
1082.
108?
No, 1,000.
No,
Yeah, 108, yeah.
108 point.
Yeah, I mean, what?
So it's 100.
108 point.
$108 per tryst.
Plus the roses, the wine.
Not going there.
Yeah.
Does that make you think about things a little differently?
But now is that on the guy point of view? Because if
Uh,
we're not married, then.
They had when I was 20 here.
Well, honestly, I think this number is way too small. The $250,000 number, I think, is way too small, but that is the current government estimate.
Yeah, when you factor in college, yeah.
Well, even not factoring in college, I think it for maintaining a thing for 20 years.
Maintaining the thing.
So I'll be working till 90. I have 5 children. I'm gonna be working till 90.
Yes, but maintaining the little creature, would you accept the little creature?
It all depends on how frugal you are.
How much is it a
If you
flight to
have to give
Vegas?
them all the bells and whistles, you know, these 5-year-olds that have iPhones.
I
Yeah.
wasn't trying
It's
to.
worse today than it was when we raised
but-
ours.
I think that this is a pretty conservative number. Just to look at the cost of clothing, housing, and feeding them. Before you start getting into those externalities, those delighters, right? Going back to the Cano model.
Mhm.
I think just the performance indicators and the hygiene factors, you're going to be over $250,000 just on feeding, clothing, and
Dental.
medical,
Yeah.
the usual, like the stuff they have to get. I think it's going to be more than $250,000 for the 18 to 20 years you're on the hook for that. So $108 per tryst. Do you think if the younger version of yourself had known that, you might have made different choices?
Yeah.
No, driven. Single-mindedness.
Well, the question is that for $108 for that night, you could have done a lot of alternate things that would have had different risk profiles.
Yeah.
So though this is a little bit of a contrived example, it's the type of choice risk-benefit analysis that you often have to do, is to figure out, okay, I know my failure rate is going to be a certain amount. How much am I going to invest in to prevent that from happening? So at American Standard, I actually was on the wrong end of a reliability decision related to this. I received a broken tub because of this problem. We knew that our packaging had a 5 to 10% failure rate on a particular tub. What made this tub kind of unique is it sold with different configurations down to about a $500 tub up to a $3,000 tub, based upon how it was equipped. And of course, we sold a hell of a lot more than the $500 configuration than the $3,000 configuration. As an employee, I got a really nice discount, so I got the deluxe version. But we knew that our packaging would fail between 5 and 10% of the time. We knew the cost of increasing our packaging so it wouldn't break was quite high. And when you looked at our numbers, when you did this calculation, it made more sense to pay out the warranty cost than it did to actually fix the packaging. Yeah. So I got the, yeah, we know it's going to break. Yeah, you're the one that got a broken one. Here's a refund. Call it a day. So in that case, it's exactly the same math, except it's applying different things. Did this help you understand the liability components and series concept and expected values? Okay. No one's going to go complain to Richard that I was too blue. You never know. It's tough to know your audience on stuff like this since it's kind of touchy-feely in the wrong ways.
I'd sequential assemble this into some other tools now. Some
Yeah.
cost-benefit analysis of.
Well, this is the interesting thing is perhaps I think differently, but regardless of what your opinions are on sex ed, I think if you explain to a high schooler this math, I think it would resonate with some of them. I think if you were to explain to a guy who's trying to scrape together $20 to do whatever, that every liaison is going to potentially cost him $100, you might think differently. And that's even with taking reasonable precautions. That even with reasonable precautions, you're still looking at $108. I just think it's not going to resonate with everyone, but I can say when I was in that demographic, if you had told me that it was going to be $100 every time, I'd be like, yeah, I'll keep my $100. I can find a lot better ways to spend $100, but that's just my 2 cents. Okay, I wanted to give us an hour to review. We've only got 40 minutes to review, but questions from the floor. Since this is your last chance to ask free for all questions.
So before we go to that,
Yep.
next, I guess we have the exam, do that over the week. Take
Yep.
the exam and then bring on this.
Yep.
Okay.
Yeah, 75 questions, so it should take us about 3 hours-ish.
Okay.
But who knows?
Did you want to
No,
score them or?
no, I don't care.
So we'll just
Yeah.
go over them.
Yeah, let's go on.
Sure.
Okay, questions from the floor. Now this is the hard part because you guys can ask me anything you want.
I'm trying to put a table together for the Kubiak.
The probability stuff.
Yeah. I don't know if it's right or not.
Okay, well, see what you got.
I-
Wow, you wrote them all out.
It's going to be the one that I can't find on the exam.
That's right.
Can they be both independent and mutually exclusive?
Absolutely.
Okay.
That's what your coin flips are. The effect, so mutually exclusive just means either one or the other happens. They both can happen. That's mutually exclusive. But independent means that one event does not influence the subsequent event. So I flip a heads now doesn't necessarily mean I get a tails on the next flip. So that column is wrong. So the example that, yeah, so the example that really highlights this is if there's actually a really good problem I put a new question on the final that really highlights this because I wanted to reemphasize to make sure when we get on the real exam, we have an understanding of it. But if we wanted to understand the fact that there's about 51% women and there's about 49% men, right? Why don't I draw this on board?
This independent column's wrong, right?
Yeah.
Okay.
But let me just reemphasize the point that we were struggling on last time, which was the probability of A plus probability of B minus the probability of A and B. So we have one population of men, right? And they represent 49% of the population, right? And we have a population of women, right? That represent 51% of the population. Without any crass jokes, these are mutually exclusive, right? For the most part. Okay. We also have hair color, right? So about 40% of the population has brown hair. right? There are both men with brown hair, and there are women with brown hair. So if we want to know the probability that someone is a woman or has brown hair, what would we need to do? If we wanted the probability of women that someone is a woman or someone has brown hair, what would we do? Well, it's the probability of A, right? So the probability of women, so 51%, 0.15, plus the probability of brown hair, okay, so if that were, if the mistaken Kubiak were true, the probability that someone was a woman or had brown hair would be 91%. But is that true? No, because what would be happening? We would be double counting the shaded region because there are women that have brown hair. Minus the probability of someone being a woman and having brown hair. Because we need to subtract out this region. Cool? Does that help?
The numbers make sense and can do the calculation. I just don't know the classifications.
Okay.
That's
So men and women are mutually exclusive.
exclusive. Having brown
Every one of the observations is independent, right? Unless you're dealing with siblings and there's a genetic component. But if you grab a random person off the street, the fact that one person is a man that has brown hair doesn't affect the fact that you grab a woman off the street that has blonde hair. So they're independent. So men and women, independent. Brown hair and men, not mutually exclusive because someone can be a man and have brown hair. Women with brown hair, also not mutually exclusive. You can be both a woman and have brown hair. That help with the terms?
So going to sit with it. But you know, the exam question hits you from a different vantage point. Here's a formula.
Yeah.
What is it?
Yeah.
That's a tough one to work backwards through.
Yeah, it is. But it's just a matter of walking through the rules. There's no other way to really approach it than just walking through the rules.
Or a crutch. Something.
Or draw the picture. Draw.
So your equation up above should have had this.
Yeah, I'm sorry.
Yeah, okay.
That was the Kubiak, so probability of A and B. Sorry. So if we were to put numbers to it, it probably would be something like minus
So the
0.2, whatever the shaded region is. I don't know, is there a gender disparity between hair color? I would assume so. Discounting dyeing. I can't come up with a reason why there would be, so I'm going to assume there's not.
so we're saying we're just assuming that that area is
0.2, yeah. What would be reasonable is to say that 51% of the 40 of it is going to, right? Because we're talking about humans. A human is, for the most part, either male or female, right?
except for those that are.
The official Rutgers policy is you get to whatever gender you identify as, so you have to.
Oh, no,
identify.
no, I'm talking about the ones that.
Yeah.
That's another-
That's a discussion for another day.
What about this? You got this table. You have hair and gender.
Yep.
You can do the sum, but what's the interior?
The interior.
Just dependent or independent?
Well,
Is that
dependent,
related? Is that
dependent, independent. Everything is going to be independent unless you can prove otherwise.
okay?
So the dependent independency depends on what phenomenon you're observing. And all that's really driving at is if I observe something, does that affect what I'm going to subsequently observe? So cases of that happening are if you're drawing cards from a deck. So if I'm drawing from a standard card of 52 cards, and I'm drawing for the Queen of Hearts. So what's the probability? Open up the deck, and I get a Queen of Hearts in the first draw. 1 out of 52.
52.
Okay, I don't get the Queen of Hearts. I get the 2 of Spades. What's the probability on the next draw that I get the Queen of Hearts? Correct. In that case, the observations are not independent because the probability changes each and every time. They would be independent if I put the card back in, I reshuffled, and then they went back around. That's the dependent-independent. The mutually exclusive comes into it either is outcome 1 or it's outcome 2. Both cannot occur together. It's either heads or tails. It either passes or it fails. There's no way it could be both. That's the mutually exclusive. So if 2 things are independent, they'll follow these rules. So the probability of event A plus the probability of event B is the probability of event A and B minus the probability of event A and B happening. If they're independent, that will always be true. If that statement is not true, they have to be dependent.
Is that a question mark or is that a 2?
That's a 2.
You calculated that.
I
No,
guesstimated.
it's-
Oh, I see, all
I
right.
guesstimated. That's why we're talking about, is there a gender disparity for hair color? And we said, yeah. It's pretty good to assume that there isn't. Any other questions related to the probability stuff? Or questions in general? Questions from the floor. This is your time. Come on. I know you got questions.
And if I had stuff from the midterm.
Okay, we can go back to those.
Yeah,
Well, we can go over question 46 from the midterm, which we didn't have time to go over.
I didn't spend much time on my own looking through it to make,
That's cool.
you know.
No, but just throw, you guys paid for the time. I'm here to answer your questions. I know when I present stuff up here, it makes sense to me. That doesn't mean it makes sense to you.
It
But
seems to make sense a lot of times when you do it, but then you think.
absolutely. Cool. What do you want to go over? Oh, there's a mistake in Kubiak's book that's really important. It's a bad mistake. And
Did we highlight that?
no, there's another bad one. It's actually a really bad one. If you go to the section on X-bar R charts, there's a big mistake. He uses the wrong N.
So it's in the back? Is it in the chart?
No, he does a worked example on the X-bar R in the book, and N is the number of observations. It is not the number of subgroups. So on the, yeah, I don't have my book in front of me, but the gentlelady from Virginia emailed me a question about it, and he's wrong.
Are we talking about around page 364?
Correct. There's a worked example for an X-bar R chart where he does an example, and he says the variance constant is something. It's in one of the boxes. Let me see if I can-
Is that-
Yeah, this one. Yeah. So
What
you'll
page
go
are you on?
363.
Oh, okay. Oh, wait. Oh, okay, down in there.
Yeah, in the box. So in calculating out the D3 constants and the D4 constants, and all the constants, he's using particularly the A2. The A2 constant is the one that's really wrong. So N is 10 in that case? Or how many observations? N is, what numbers, how many observations are there per?
1, 2, 3,
Yeah.
4 per subgroup. 1, 2, 3, 4, 5, 6, 7, 8. 10 subgroups, 4 per
Yeah, N should be 10, and the A2 constant should be based upon 10. He did it based upon 4, and he's,
It should be 4.
no, it should be 10.
That could be infinity. It's always the number within the subgroup.
Yeah, the number within the subgroup, exactly, not the subgroups.
Right, so there's 4.
No, it's 10. There's 4 subgroups, and each subgroup contains 10 data points.
Then it goes left to right.
Yes,
A row is the data,
yes,
all per day.
yes. And if you look at the chart, he's plotting days.
Oh. That's a grad student who did that or something.
Yeah, that's a baddie mistake.
Okay. X bar was over here then, not underneath. See, they did it this way, thinking this was a group. The sample is actually this way.
No, well, no. So
7 to
if you look at the graph, he actually draws it out on the next page. See,
10 subgroups, 4 samples per.
maybe it was different in my book, but just make, so on our example on the midterm, it should be based upon the number of, just make sure you understand how you're subgrouping it. So if your subgroups are the hours, then subgroup it that way, or it's the days, subgroup it that way. Just make sure that the number of observations per subgroup are the number that you're actually using in determining your control chart constants. I think there might be a difference between the printings of the book, because that just looked like it was right. In my book, there was 4 data points.
This one's right, the D, the
Yeah,
char's right.
I think you might have a newer printing, because my book was wrong. But don't worry about it. Just the key important concept there. If you look at the example in the midterm, you should be using 6 because there were 6 observations that went into every point, not 5. There's 5 days, 6 data points each. So you should use 6 for your determination of your control chart constants on whatever number that was in the midterm. It appears that your printing of the book is correct.
On this one, his questions are horrible in this one. There's some
Yeah,
answers that are.
yeah.
on the CD.
Yeah. I tried to fill, as you can see, I swiped some of the questions from there. I tried to swipe the ones that were good. It's hard to write good questions. There's one in the final that you're going to hate me for that I really like, and I'm not taking it off. It involves a bike. Bicycle.
So he or ASQ should publish like a
There
correction
is.
erratum.
If you go on the website for the book, there's an errata file.
Where? Whose website?
There's a website for the
Authors at ASQ.org?
no. There's a website for the book. I think it's mentioned. It's mentioned somewhere.
It's ASQ Groups CSSB Handbook.
Yeah. Yeah.
There's errata?
Yeah. I think I'm 90% certain there's an errata file there, which I should probably check and have it.
That's good to know.
So you had a question about what question on the exam?
Yeah, once after that, I'll see if I have another question.
Okay.
Yeah, sorry about that.
Yeah, no,
So
no,
interesting.
That's fine. I have a question here. All right, oops, sorry, guys. A scoop sample is 100 units trial. What must be the average number of defects? Because that would be an 80% chance that more than one defect will be found in the sample.
What number is that?
Number 40.
Okay.
That's binomial. Is what we.
So we're dealing with number
40.
It's the one where you.
Oh, this is the final.
You did it by 2 or greater binomial, something.
Yeah. Let's jump back to that. So
Where you drew this.
yeah, I draw pictures and let's go walk through it. Okay. So a scoop has 100 units trial. What might be the average number of defects for there to be a 80% chance that more than one defect will be found in the sample? Okay, so we want to know the number of defects, right? And we want to know more than one defect.
Right.
So we want to know the probability of 0 defects and the probability of 1 defect, right?
Right, it would be 1
1 minus the probability of that plus the probability of that.
Okay.
That help?
It does.
Can you do it using this formula
Uh,
and work backwards, or no? This would be the result you want?
I have that'd be the hypergeometric. Yeah, you
What's the
probably could. You probably could. But this is one of these understand what the problem is saying. So
Yeah.
probability of 0, probability of 1, and then just subtract.
What do you mean? Find the cumulative CDF?
No, you can do the CDF of 1, or you can do the PDF of 0 and 1. It'll give you the same value.
Then add them?
Yeah, then add them and subtract 1. Because when is the statement here? What's the region? If we draw the picture, what's the region we care about?
We found the area under to
Yep. Yep. Well, let's just draw the picture about where a good region is and where a bad region is. Okay, so what's our solution space? We can get 0 to 100, right? Okay. So it's going to follow the binomial distribution, which is more or less normal. Okay. So what region do we care about?
Greater than 1 defect.
Okay, so we want 1 defect or 0 defects. Those are the two. That's the region we care about, right?
Right.
But what must the average number of defects be for there to be an 80% chance that more than 1 defect can be found in the sample? So we want this region. So from 2 to 100 to be 80. Therefore, what must the, including 2? So what must the region in black be? 20 or less percent.
How do you? It asks for n. That'd be 100.
No, and it's, well, yes, but the complicated part about this is asking what the defect rate needs to be.
Yeah, the pigs.
Yeah, so you kind of have to guess and check it.
Okay.
Yeah, that's what made this problem kind of hard, is you have to guess and check it or do the algebra. And it's kind of a pain in the ass because you're doing it with power.
Right, so you just guess with, right?
Yep.
Okay.
But if you can draw the picture, it kind of lays it out to what you're going at.
Sure.
So I entered 0.8, and it gave me a crazy number. E to the minus 70.
Okay.
Something's wrong. Your way
No.
is so fast.
No, you wouldn't do 0.8 because you want this region to be 0.8.
Oh, 0.2 then.
No, you don't even want that. What they're asking you for is the defect rate when they're asking you for the rate. So they're asking you what you're trying to solve for here. So what you really want is an inverse binomial distribution, which it doesn't have a function for that. So this is akin to like when you want to calculate out what the z-value is for a given value, where you look at the area under the curve and then try to figure out what the z-value is. It's kind of what you're trying to do here. And you don't have an inverse binomial distribution. So you kind of have to guess and check it. Or do the annoying math. It's easier to guess and check.
Oh, so 0.03 would be the number you'd arrive at. Oh, no, that's what it would display.
Yeah, if you enter in 3, you should get the right answer. Well, that was the right answer, right?
Yeah, 3 was the right answer.
Drawing the picture always helps.
That was,
Next victim.
What's it asking with the chi symbol, the x?
That's the value you're targeting. So in this case, it would be 1, because that'll give you, if you're doing this CDF, it'll give you 1 or less. So 1 or 0 in this case. Okay, next victim. pretest, we can go over any of the slides, or anything you want. Or we can do my question 46, which no one liked. Okay. Because you were so close of what you were saying on 46 about your methodology was right up until the last step. Yeah, 46 was the gambler problem. That's if you roll a 6, you stay in the game.
That's the thing.
Okay. So what's the probability of rolling 3 6s in a row?
0.166.
Well, 1 6 times 1 6 times 1 6, right? Because dice rolls are independent, exactly. So the probability of event A, well, I know that's probability of a 6 plus, and probability of a 6, and the probability of a 6 equals that times that times that times that, which equals what?
0.0046.
0.0046?
But that's when I said that was per person.
Yes, that is per person. Okay. So now we have a defect rate of, or a success rate, it's called success. Of 0.0046. Okay. And how many trials do we have?
Well, 3 times
No, how many trials do we have? How many people did we start with?
1,000.
Okay. Kind of looks like the other problem we were just doing, right?
So
So what's the problem asking us? How many gamblers would you expect to remain at the 95% confidence level? Okay, so let's draw our binomial distribution approximation with normal. Okay, so what are the possible outcomes we can have after 3 flips? How many people can be in the game? We could have 0, right? Everyone could be eliminated.
Right.
We could also have 1,000. No one's been eliminated. So we want to know what number will there be at least 95%? What's the question asking? 1,000 gamblers start rolling dice under the condition that if they roll a dice, they can stay in the game. After 3 honest rolls, how many gamblers would you expect to remain at a 95% confidence level? So what does that mean? So we have some number here, right? How do we figure out what that number is? Well, CDF, right? So we just need to figure out what the question mark is such that this area is 95%.
Under the curve.
The shaded region.
So from negative infinity
Well,
to,
no, can't go negative infinity.
oh, it's binomial.
Binomial. We can only get 0. Our solution space is 0 to 1,000.
Okay.
We want to know what value between 0 and whatever. Well, 95% of the time will we observe that value or fewer left in the game. Okay. Next victim.
Where do you enter the 0 and 1?
Everything.
It's confusing. You know how to do it.
Okay, so the probability of a success is, we know what the probability of success is. That was 1/6 caret 3, right? 1/6 times 1/6, 1 times 1/6. And our probability of and the number of successes we're looking for is that's what we're trying to figure out. Right, and we want to be in CDF. Binomial CDF, number of. So we see if we do it at 7, we get 0.9, and if we do it at 8, we get 0.953. So our answer is somewhere between 7 and 8.
Yeah.
So what did you enter for the parameters there?
Okay, 1,000 for n.
N equals 1,000.
P equals 1/6 to the third.
0.006.
Yep,
Because there were 3 attempts.
yep, 3 attempts. The probability of a success is
Okay.
flipping 3 6s. And then we're looking for 95%. So that occurs somewhere between 7 and 8.
That makes sense.
Yeah, unfortunately, it should, when I give this again, it would be, I'm going to reword expected to remain at a 95% confidence level to be clear as to what I'm asking for. I think that was the confusing part, and honestly, it's not well worded. But that's where I was trying to go with it. Was to make you realize that the probability of a success here is basically the 3 successes. Right? So you were on the right track. You just didn't go the last step. Because you kept,
Because I multiplied
You
1,000 times.
Yeah.
4 points.
that's the expected value. Yeah, that's the expected number. But again, we're trying to, I was trying to make you go a little bit.
So really,
You were on the right track.
with that, if that was the expected value, then you have to times that by.
No,
not times by.
No, because we're actually on a confidence interval here, so you'd have to do an approximation for the. Oh. That's kind of cool. Ooh, I like doing it
If
that
you
way.
times that by
No.
0.5,
Actually,
0.05,
so we have actually a confidence. We would basically have a confidence interval for proportion, which is kind of cool. That's why I should be. I was thinking and writing at the same time.
0.63, and if that was times 0.05.
P plus minus C alpha over 2 P 1 minus P over N, right? Confidence interval for a proportion? Square root? What's the formula for confidence interval for a proportion?
It's at home. They're looking Kubiak.
I think there might be a square root there.
One-year science.
T-test for mean paired to population means every page buffering. Here we go. Square root of p hat.
Yep.
1 minus p over n.
Cool.
You're right.
Hey. Okay, so in this case, we have 1/6 to the third plus minus 1.96 square root of P 1/6 5/6 Yeah, that's why that doesn't work, because we know what n is. Okay, cool. Yeah, I have to reword the question, but I wanted you to use the CDF there.
Yeah.
Okay, next victim. Come on.
number 16.
That was the clever algebra.
Yeah, okay. This is a confidence interval for means. So what's the confidence interval for mean?
T,
0 to
Yeah, what's your sample size here?
10.
10, so we're gonna go T. T alpha over 2. Then we have sigma over the square root of n. Okay, so we know the 18, we probably don't even need to know it. T alpha over 2 for 9. I'm sorry, for 0.90.
I don't have the table, so
I don't think we even need to know it. So we'll just leave it in the formula as is. Okay, sigma, do we know what sigma is? 2.5. And we're solving for m-ish, right? Because we want to know their relationship. Well, we know right now that n equals 10. Right?
Mhm.
Okay, so we know that, we know that, we know that, we know that. We know everything, right? For the first part. We can solve that, right? Okay, so now we want to do the second part of the problem, which says that we're going to change n such that we want to have what? So let's write our formula again. So we want to change our samples, we want to determine what sample size we need. So our sigma is going to remain constant, our mu is going to remain constant, and our T alpha over 2 is going to change a little bit, but close enough to being constant. So we want to solve for our N1. Yeah. Okay, so what's the relationship between our start and our finish? So we want our finish interval, right? One half of our start to equal our finish. Okay. So we have mu plus T alpha over 2 sigma over square root of n equals mu plus T alpha over 2 sigma over square root of n1, right? Good. Now it's just algebra. So let's start putting the numbers in. So mu is 18 plus, anyone know? Did anyone look it up?
for what T?
Yeah.
At 0.055, it's 3.250.
Okay. 3.250. Sigma was 2.5 over the square root of 10 equals 2 times, or why don't we just leave the 1/2 there since we have all the numbers. So 1/2 times that mess, what's that equal?
So the last time you did like a cross multiplication.
Yeah,
You crossed out, I wrote that down.
Yeah, I was shortcutting to save us a little bit on time, so I just wanted to walk us through actually what I did when I was
Uh-huh.
when I was crossing out.
it's 18 plus or minus 2.57. But the left-hand part, I didn't do the whole thing.
Okay. We only care,
Yeah, it's kind of-
we only care about the right-hand part, right? Because we don't need the mu, because the mu's on both sides, right? We want to change our thickness of our interval.
I got 2.57, and then 1/2 of that.
Yeah, 2.57,
1.28.
okay? So this guy equals 3.25 over sigma, which is still 2.5, over the square root of n. What's 3.25 times 2.25?
8.13. $66.
You know what?
Yeah, the answer was 40, that's,
Why did that work out that way? Where did we do from?
You got 40 last time.
Yeah, I know why I got 40 last. I goofed up in our math somewhere. I will, you know what, let me work this one up and we'll start class at the next time on this, because we goofed up the math somewhere. Because it should be 40. Where did we goof it up? It's not coming to me right away, so we'll start with this in first thing next class. Any other last minute questions?
I think I must say.
Again, 8.13 divided by 1.28.
8.13 divided by
1.28.
6.3.
There we go.
Yeah, okay.
6.3,
Squared is.
6.35 squared.
40.3.
Yep.
the,
Okay. Yeah, I forgot when I was asking you to calculate for me. I forgot to do the last division.
that was number 60.
Yep.
How did you catch that looking at it?
I was stepped through the alphabet. Unfortunately, when you generally when you condense the steps and you're doing them out, you sometimes forget to do the step. I knew the answer was 40.
You knew what the answer was. It should be. You got
Do you
it.
have a
Okay, see you next week.
Do you have
See you
a
next
good-
week.
Good
Oh, no, I'm good.
resolution?
If you want some coffee, take some more coffee for the road.
Thanks, I'm okay.
The
Yeah,
resolution.
I think that those travel mugs are, what do you want to look at?
When I took the pictures, I had an email resolution. You couldn't read a number to save your life.
Yeah, for some reason, picking up the whiteboard is really hard. It screws up the white balance of the camera.
Well, here, when I stretch it, take a look. See,
Yeah, as long as you can read it. And I'm not gonna
See you
read
guys next week.
You good.
Thank you for tolerating me. Thank you
it. Yeah,
for
very good.
tolerating my little screw up there on the board.
Well, thank you. Thanks for the coffee. Thanks for the
Thank you.
calculator.
Yep.
Appreciate it.
See you guys next week.